Hello and welcome to Learning Express Web Application Development video tutorial. During this video, we'll get Node.js and its dependencies installed on your computer. Express.js is a small and flexible tool for building websites completely with JavaScript. In order to use it, we need to first install Node.js and the package manager NPM. Once we have the tools installed, most of the information in this course will be the same, no matter what OS you use. However, the first step of installing Node.js does depend on your OS. The good news is, no matter if you use Windows, macOS, or Linux, the installation is easy. So we'll cover all three options quickly in this video segment. If you're a Windows user, the best step is to go straight to the nodejs.org website, and right on the homepage, click the Install button to download the Windows Installer MSI file. Once the download completes, simply open the installer and follow the instructions. Mac users have a few choices. You can always install the same way as the Windows user did. However, a better long-term solution is to use Homebrew. Before you can install Homebrew, you first have to install the Apple developer tools. To do this, open the terminal app and type this command, xcode -select -install. A nice user interface pops up to help you install the tools. Once installed, use your web browser to visit brew.sh and scroll to the bottom to see the installation instructions. There you will find one long command that you need to run to do the installation. Copy and paste that into your terminal. It will explain what it's doing and walk you through the steps. Once complete, installing Node.js is as easy as typing brew install node. There are many versions of Linux, and all of the popular ones support Node.js just fine. As a matter of fact, if you're using Ubuntu 13.10 or newer, you can simply install Node.js from your package manager and have a reasonably up-to-date version. However, even if you're using a newer OS with Node.js available via the package manager, I suggest instead visiting the nodejs.org website, clicking the Downloads link, then scrolling down and clicking Installing from Package Managers to see a list of instructions specific to each version of Linux. Because each version differs a little bit, I won't go through each of them. I'll trust you to figure it out. Once the installation is done, let's confirm that Node.js is installed correctly. From your terminal, type the command node -version. You should see the version number listed. Now that you have Node.js installed, you also have the NPM package manager installed. This tool makes it easy to install supporting tools for your Node.js apps. We're going to start out by installing Express.js, but first you need to understand there are two ways to install a package. The most common way to install a package is for just one project. However, we want Express.js to be available for all projects, so we need to do a global install. Furthermore, we're not going to actually install Express.js globally. We're going to install the Express.js generator. This is a simple application that will create new projects and set them up to use Express.js. So open your terminal and type npm install -g express generator. We're using the -g so that the package manager will be installed globally, which means computer-wide. You can check that Express was installed properly by typing the command express -version. If you see a version number printed, it was successful. Unless you received errors along the way, we now have Node.js and Express.js installed, as well as the package manager NPM. Keep watching, and we'll learn how to use it. If you're a Windows user, there's a special step you'll need to follow whenever you want to use Node.js or the package manager. Most tutorials on the internet fail to explain one critical step for Windows users to follow. So if you've tried to get started on your own and been stuck, it might have been because of this. When you installed Node.js, you got a new app called Node.js Command Prompt. This launcher opens up a terminal with special settings required to have success. It really doesn't look much different than the normal command prompt, but if you use this one, then Node.js and NPM will actually work. Remember, as you follow the steps in the rest of the video series, whenever you see instructions to open a terminal, use the Node.js command prompt. If you get nothing but errors, make sure you have the right command prompt open. During this video, we will show you how to quickly build a basic Express.js app using the command line tools. This app will have all the basic features of a web app, and when we're done, we'll be able to view it in our web browser. Express.js is happy to let you start building a new web app from scratch. However, there are few things as intimidating as a completely blank canvas. The Express.js developers have therefore included a tool that will build out the structure of our app and even give us a few sample pages to start out with, to make it a little easier to get started. You see here, we have an empty folder. This is our blank canvas. We need to open our terminal and change to this empty folder. The cd command changes directories. I've created the folder called project1 in my home directory. I can change to that directory in the terminal by typing cd project1 and pressing enter. Now that we're in the correct folder, let's bootstrap the app. We do this using the express command. Before we do create a sample application, type express -- help so that we can see what our options are. By default, if we just type express, we'll get an application that supports the Jade template engine and standard CSS syntax. We'd like to add Stylus CSS support as well, so we'll type express -- CSS Stylus and press enter. Note that the other built-in options for CSS are less and compass. Compass support implicitly includes Sass support. You'll see that a lot of information scrolled past the screen. This is the Express script creating our sample application. One of the most important files of any Node.js application was the first file created, the package.json. We'll discuss it in detail a little later, but the quick explanation of this file is that it lists all of the dependencies of our project. In this directory, we simply need to type npm install, and the npm package manager will read that file and install all of the required modules. This can take a little while, depending on your internet connection speed. We can use the command npm start to launch the application. You'll notice not a lot happened. If you switch to your web browser and visit the URL http://localhost:3000, then you'll see a sample page open up. If you view the terminal, you'll see that some information showed up. This means it worked. The requested web pages and the required information were served to the browser successfully. We can tell because of the green 200s. Had there been a problem, we'd have seen some errors shown. Don't worry, we'll get the opportunity to see some errors as we dig deeper into our project. The reason that worked is because Node.js and Express have a built-in web server useful for doing local testing. The npm start command launched the server on localhost port 3000 so that we can see the newly created website. Press Ctrl+C to close the server. If you were trying to refresh your browser now, you'd get an error message saying the browser couldn't connect to the server, which is logical since we shut the server down. For now, we know we have all of the pieces installed correctly, the Express command line tool works, and we've been able to view a simple web page in our local browser. If we look at the folder where our project lives, we'll see all of the files created. Now you know how to bootstrap a new Express.js app, install dependencies, start the local development server, and then close the server. Next, we'll look around to see what all these files are for. We've seen it work, now let's get a quick understanding of what's going on under the covers. If you've ever edited plain HTML files on your computer, when you previewed them, the URL looked long and ugly, and it started with file://. However, our URL looks more like a website. Most real web servers run on port 80 for HTTP requests. However, on your local computer, it probably requires special permissions to use port 80. Instead, we use port 3000, which is why our URL looks a little different. We access our local site using HTTP, the website is localhost, and the port is 3000. Therefore, the URL is http://localhost:3000. We can include standard static files in our application, like CSS, images, and JavaScript files. This appears to be a simple HTML page, but as you'll see in the next section, the HTML page was actually built with JavaScript on the server. It was built from a template and includes dynamic data. Having a built-in local development server makes building and testing Node.js apps much easier. No need to upload your files, simply refresh your browser to see the changes. In the next video, we'll look at the code that makes all of this happen. Let's take a look at the structure of an Express.js app. You've probably noticed that our application has a lot of files. Most of these can be ignored as simply the magic of Express.js, but some of them will be important as we continue on and customize our project. When a Node.js project has dependencies, for example, this project depends on Express.js, you list these in the package.json. You can do several things with the package.json file, but for now I want to focus on dependencies. This is a list of all the modules a simple Express.js app uses. First and foremost is the Express module. When we run the npm command from our project, npm looks at this file and downloads and installs all of the dependent files. You'll see here in our project that there is a folder called Node Modules. This folder was auto-created for us by npm, and that is where it installed all of the different modules. In most cases, you never need to mess with this folder. As a matter of fact, if you use version control, you don't need to check in this folder. It may contain files configured specifically for your computer. For example, if you're on a Windows computer, then some of your files may be different than someone on a Mac. If you have a custom created module, normally you would list it in the package.json with a reference to wherever you keep that module, and npm will install it for you. Likewise, we now have a bin folder. Here you will see a single file which is used by Node.js for launching a local developer server. On some platforms, you may not have this folder or the same file in it. This again was auto-generated for us and we don't need to mess with it. Your apps will need static resources, for example CSS files, images, web fonts, and client-side JavaScript. In most cases, these can be served directly by a web server. With one exception, everything in this folder is served simply and directly as it is. There is one exception, and that is the Stylus files, or in case you're using Sass or less, then your SCSS or less files. Most developers will use a tool to combine and compress their style sheets before going to production. However, these files are hard to work with during development, so in our project, Node.js knows that if a request is made for a CSS file and it finds a Stylus file with the exact same name, it will quickly compile the Stylus file into CSS and serve the CSS. This is amazingly useful for local development. Just remember, don't edit the CSS file. Instead, edit the .styl file. Here, inside the routes folder, you'll see some JavaScript files. This is where we'll be putting our logic for simple apps. It's pretty much a switchboard. The Express.js developers give us two examples, though only one does anything initially. You'll see here in the index.js file that we have one function defined and exported. It doesn't do much, it just renders a view called index anytime the root URL for our site is requested. Speaking of views, let's take our first look at Jade and the auto-generated views. Notice here that we have a file called index.jade. As you might guess, this file matches the index view that is rendered in our index route. It's a good idea to use consistent naming on simpler apps. However, don't be afraid to use a naming scheme that suits your needs if your application becomes more complex. There's no magic in the file name. You'll notice a couple of things about this view. First is there's not much to it, and second, it's pretty clear what's going on. We're simply showing an h1, which is set to the value of the title variable from our route, and a p tag, which has a message and also contains a title variable in our route. We'll dig into Jade a little more soon, but this first line is important. It shows that we've extended a layout. When we open that layout.jade file, we see that it contains the parts of the web page that are used on multiple areas of the site. This is the wrapper HTML. Again, the beauty of Jade is in the ease of reading. The last thing we need to look at is the app.js file in the root of our project. For the first time, you're starting to see what looks like a serious amount of code. For the work we're doing, we don't need to dig into this too deeply, but I want to briefly cover what's going on in here so that you can find your way around. You'll see that the first block of code is related to the required modules. These modules are used by all of the app, so they have to be imported here. Note that you can also require modules in your routes or in your external modules you create. The next line instantiates the app. Then, the next few lines set configuration options. Notice here on these lines that we have app.use statements. This is our middleware code, and any non-trivial app will probably add some custom middleware. For example, we'll add middleware for doing authentication later on in the tutorial. Here you'll see where our routes are actually wired up. Note that in our route index.js file, we specified router.get /, and then in app.js, we do app.use /router. What this does is it creates sort of a namespace. In this case, we're saying that router index.js gets the root. In the example, we also have a route set up under the user's namespace, and the routes for that URL are defined in the routes/users.js file. The last chunk of code here sets up the error handling code for development and production environments. And then this last line exports our app, which is the last step needed to allow our app to run. So here we've covered the files in Node modules and bin and discussed how the package.json file dictates what will appear in that file. Then we browse through our public folder to see static files and our compiled Stylus CSS files. Then we looked at our routes and views to see how the HTML files can be served. Finally, We browse through our app.js file to see the initialization code in our app. In the next section, we'll be learning about the Jade template engine, the Stylus CSS preprocessor, and how to use Bootstrap in our project. Many of your websites are going to have a front end. You may be surprised that I didn't say all, but you're definitely able and encouraged to create API backend applications with Express.js. For example, you may create a native mobile app that simply needs a server-based backend. But in practice, you're usually going to have a web-based front end, which includes some HTML, styles, and probably front-end JavaScript. In this video, we'll be digging in a little deeper into the Jade template engine. This is a server-side rendered template engine that creates plain old HTML pages that can be viewed by any device, even if that device doesn't have JavaScript enabled. When I first used Jade, I didn't like it. I was used to HTML, but I forced myself to explore and see how it worked. When I was done, I looked at my code and was amazed at how easy it was to read. Like Python and CoffeeScript, and as we'll see soon, Stylus, Jade uses indentation to denote nesting. Therefore, there are no closing tags to keep track of. You can see from this moderately complex document that the markup takes very little vertical space, and the indentation helps you visually group elements together. Of course, with standard HTML you can do this too, but the difference is in Jade you must do it, and therefore your code has to be tidy in order to work. It's not hard to find an editor that understands HTML, and while you don't need to have Jade support specifically enabled for your editor, it can be helpful. In this tutorial I'll be using the Jade plugin for Sublime, and I've also used the Jade support for WebStorm with great success. Vim also has Jade configuration options. When enabled, these plugins will use more intelligent indenting and syntax coloring. Regardless of what editor you use, make sure that your indentation is consistent. Jade doesn't care if you use tabs or spaces, nor if you use 2 spaces or 4. But you have to pick one setting and be consistent in the same file. I'd suggest creating a standard for your team and implementing it consistently. In the Jade community, I've commonly seen 2 spaces used. Here is one of the simplest HTML docs you can imagine. It has an HTML5 doc type, a head section with a title and a linked style sheet, and a body that contains a headline and a paragraph. You'll notice that the nesting is clear due to the indentation. The title tag is nested under the head, which is nested under the HTML. Sometimes you need to add an attribute. For example, an A tag will have an href attribute. In this case, see the linked style sheet tag here? It has 2 attributes, the rel and href. To create these attributes, we simply need to use parentheses and then separate the attributes with commas. You'll often need to use IDs and classes to make styling easier. In the case of IDs, we use the CSS style of notation and include a hash directly after the tag name. For example, h1 hash page title. For classes, use the CSS dot notation. For example, p.hero. You can have multiple CSS classes by using multiple dots. For example, p.hero.grid12. You'll often find that many of the web pages in your site use the same outer shell and only the inner portion of the pages change. In times like this, you'll want to use the extends keyword. You create a layout, which is just a standard Jade file, but it will contain a block that has a name. In this case, our block's name is content. You can have multiple blocks if you like. For example, a blog might have a content block and a comments block. Then in your template, you use the word extends at the top of the document to indicate you want to extend another template. In this case, we'll extend layout. Then we use the block document again to indicate the content we want in the block. Nested in the block, we just use normal Jade syntax. In some cases, you may have some markup that gets used in multiple places. Don't repeat yourself, use includes. These are bits of code that are stored in a separate file. Whenever you want that content to appear, you simply include it and it will appear. You'll probably want to use some dynamic data. For example, a blog app will fetch the details about an article and pass the article information to Jade to display it properly. If we look at our route, you'll notice the res.render function takes 2 options. The first is the name of the template to use, in this case index, and the second option is an object that gets passed in. Right now, we only have one element of information, the title. We can add as many as we want. Here we'll add a value for the headline. Now when we switch back to Jade, we use the equal sign after a tag name if the entire contents of the tag will be the value of the variable. In this case, the h1 will be the title. If you want to include a bit of data inside some other content, then we'll use the curly bracket syntax. In this syntax, we add the variable to the paragraph. Every once in a while, you'll have some code that doesn't work right. One way to make debugging easier is to just turn off code you may suspect is causing a problem. You can do this by commenting code. You can comment out one line of Jade using the same syntax as JavaScript. If you comment this way, the commented code will not be visible in the resulting HTML source. You can also comment code by nesting some code under a comment tag like this. This lets you comment out multiple lines pretty easily, but the Jade code will be visible as an HTML comment in the output. Sometimes you want to do different things depending on the data that gets passed in. For example, if there is a name, then display it. You can use the if-else syntax like this: if, name, else, etc. If you want to do the opposite, Jade also has an unless statement. This causes the code to appear as long as a variable is false. In my opinion, our template should be as simple as possible. That means we should not use complex logic. Logic should be in your JavaScript, not in your template. If you need conditionals more complicated than if something exists, then you need to rethink how you're passing your data through. In computer science, this is called separation of concerns. Templates are concerned with displaying data. Processing that data should be done in a route or module. Sometimes we need to do something multiple times. For example, for each item in a list, we need to display a bullet point. This is called iteration, and we'll use Jade's each command. Since JavaScript has two kinds of lists, arrays and objects, there are two ways to use each. The first way simply says each item in list, in which case item is a new variable available in the following nested code. Notice that like the if statement, you can quickly tell which code is part of the each block because it's indented. If we want to iterate over an object, we can do the same thing, but we may care about the key. If we edit our route, we can add an object to the data passed through the template. Then we use each item, comma, key in object. In this case, item is the value, and key is the name the value is assigned to. If we use this syntax on an array, then we'd get numbers. Sometimes you'll bump into errors when writing your Jade templates. The most common relate to indentation. This can be manifested in incorrect HTML, or if you really mess up the indentation, you may get a Jade compilation error. If your editor has a mode that shows you whitespace characters, try to turn it on. In this mode, spaces and tab characters will look different, and you can identify code that is indented improperly. Another great way to have a problem on tags with multiple attributes is to forget the comma between attributes. In any case, your browser should provide details about the error, including a line number. The line number may be off, but it's usually close, so if it says line 9, also check lines 8 and 10 as well. Now you should have a good overview of Jade. You'll be able to build many of your common tasks and use both static and dynamic HTML. There's more to learn, and we'll build on this knowledge as we start to build our project in upcoming sections. Next up, let's discuss the Stylus CSS preprocessor. Stylus is a CSS preprocessor that uses a Jade-like syntax and some programming language-like features to make CSS more powerful. The result is a standard CSS file. When you're editing CSS files on a large product, there can be some duplication of effort. For example, you may have a specific color that is sprinkled throughout your code in many places. What if you could define that color once in a variable and then use that variable again and again? Then if you need to adjust the color either slightly or drastically, you simply need to make the change once. Stylus allows this, and it can do a lot more. Like Jade, it strives to be readable, but unlike Jade, it's very permissive in the syntax you use. You can put plain old CSS in your Stylus file, and it will work. Don't like the braces? Get rid of them. You can ditch semicolons too. You can also get rid of the colons as well. If you have a little bit of CSS that you use again and again, you can make a mixin out of it. Let's create a mixin here that sets the border radius using the various prefixed options. Note that even the parentheses are optional. I like to organize my Stylus files by their function. I'll often have a file that sets my variables in per project settings. I'll also include any mixins that I want. Then I'll have a reset style and any vendor library such as Bootstrap. Then I'll have styles specific to my app in a separate file that gets included last, or I may just put it at the bottom of my site's main Stylus file after the imports. Stylus has some built-in functions which work just like mixins. There are too many to list here, and a lot of them are uncommon, so I suggest you read through the Stylus documentation after you get the basics down. You might find something that can give you some extra features. Some that I like are lighten, which takes a color and a percentage. Likewise, there is a darken that works the same way. These are nice if you want to use a complementary color. You can also desaturate and saturate a color. There are also functions for getting image sizes and doing more complex math computations. Notice that I can import CSS files. If I do this, they will be @imported, just like they would in CSS. They will not be combined into a single file. Sometimes you need to remove some Stylus styles temporarily. You can comment out a line just like you would in JavaScript, using 2 forward slashes. If you want to comment out multiple lines, you can do C-style comments with /* and */. If you want commented lines to appear in the output, then I put an exclamation point after the opening /*. I don't usually have syntax errors in my Stylus code, but if you do bump into one, note that you'll see the errors in your browser just like we did with Jade. These will include line numbers and the file with the problem. The most common issue I've seen is that I've tried to import a file that doesn't exist, probably because I typed the file name wrong. These are easily caught and fixed. So now you have a general overview of Stylus. One of my favorite aspects of Stylus is that it allows you to use as little or as much of it as you like. This makes it pretty easy to start using CSS and gradually adding more advanced features as you move on. Next, we'll discuss the Bootstrap framework. Bootstrap is a library of components and styles that allow you to quickly build attractive and usable websites. You get a lot for free. I strongly urge you to browse through the documentation just so you get an example of all that you can do. We'll be using Bootstrap in our project, and while I will give you an overview in this video and some hands-on experience later on as we develop the app, we could spend the entire video series just talking about Bootstrap and not run out of things to discuss. Normally when you download Bootstrap, you'll get HTML and CSS. The developers also offer Less and Sass versions instead of CSS. Less and Sass are similar to Stylus. Remember that you can always take the unminified Bootstrap CSS file, rename the extension from CSS to STYL, and then @import them. You'll also need to add the JavaScript files to your final HTML if you want to use the JavaScript components. Some of the JavaScript components you may want to use are modal dialogues, drop-down menus, tabs, tooltips, or the similar but fancier popovers, alerts, collapsible accordions, or fixed elements. In our application, we'll primarily focus on just Bootstrap styles. One thing you'll notice when you use Bootstrap is that many elements have multiple CSS classes. This can cause your templates to look a bit complicated. However, I still appreciate how compact Jade templates are. In this case, we're looking at a navigation bar using Bootstrap. The syntax for this was derived right from the Bootstrap documentation. Bootstrap buttons make great calls to action. They just scream, "Click me." You can make a button out of an A tag, an input button, or a button tag. You just need to add these classes and then a role attribute. One of the most commonly used features of Bootstrap is the responsive grid. This helps you make a website that looks great on both desktop and mobile browsers. It will expand to be multiple columns on wider screens and compress down to a single column on small screens. The syntax is pretty simple. You need an element to be a container, an element for each row, and within each row, you denote the columns with a .col- syntax. The last thing we'll discuss, and the part of Bootstrap we'll use most heavily in this project, is the form controls. These are a set of nice-looking, usable, and accessible form controls that work great in data entry apps. Yes, you could write less code, but these controls give you a lot for the low cost of a little markup. You decide if you want to have standard forms where the labels appear above the controls, inline forms where the controls are all side by side, for example the search field, or horizontal forms where the labels appear to the left of the control. Here we see the basic controls. They each come with example HTML markup that you can use to create a consistently attractive and accessible form. The only thing you'll want to take particular note of is that input tags need to have a type attribute. You can choose from any of these input types. Normally, in a browser, if you leave off the type, you get a plain text field. With Bootstrap, your text field won't look like the rest of your form controls. The last aspects I want to bring to your attention are input groups. These let you create custom form controls by combining labels, buttons, drop-downs, and text fields. For example, if you wanted to provide a form field where people enter their Twitter username, you can use it in an input group that prepends the @ symbol. If you had checkboxes and you wanted an other field, you can use this input group that combines a checkbox and a text field. Here's an input group that includes a built-in dropdown. This gives you a lot of options. That is Bootstrap in a nutshell. We'll get some actual hands-on experience with it in section 4 when we begin building the interface. One thing that has contributed to the popularity of Bootstrap is the excellent documentation. So as you work through this training series and move on to develop your own projects, be sure to read through the documentation to look for interesting features you can use. Next, we'll learn how to deal with static files. Most modern web apps will have a variety of static files. For example, you'll need a place to store images, font files, and JavaScript. Fortunately, Express.js provides a simple solution to help you during your development. When we browse through our project folder, we see the public folder. This is where we serve our static files. Everything in this folder is served exactly as it is here, but without the public folder. For example, if I create a file called public/hello.html, then I could view that file as http://localhost:8000/html.html. Notice that I shouldn't put public in the URL. The Express command line utility created some folders for us to use. We can create our own folders if we like. There's no rule that says we have to use these predefined options. However, I would strongly suggest using a few folders for all of your files. When you publish your sites live, You'll have your web server serve these static assets, not Express, and each folder needs to have a rule associated with it. We can simplify our server configuration by having fewer rules if we have fewer folders here. If I drop an image in here, then it will be visible at http://localhost:8000/images, just like you'd expect. You can put any kind of images here that you'd put on a regular website. If you want to use Flash WSF files, or videos or animated GIFs, that's fine. It's becoming increasingly common to use web fonts in projects. If you have a web font you want to use, for example, the Glyph Icons font bundled with Bootstrap, you may want to create a fonts folder here to store your fonts. This folder works just like the images and fonts folder. Whatever you put here is served exactly like you saved it. For example, if you like AngularJS, you can put its files here in this folder. I do want to call out one special point. It's a good practice on larger projects to break your JavaScript into modules, often in the same folder. You can do this manually, or you can use something like require or CommonJS to magically combine them. Whatever you do, just realize that Express is not going to create anything for you automatically. If you have multiple JavaScript files that you'd like to combine and minify, you'll need to incorporate a build process into your publishing state that does this for you. A popular tool for doing this is Grunt, which can use the uglify rule to combine your multiple human-readable JavaScript files into one ugly, but rather small file. Now you understand how the static files are served. This isn't rocket science, and I have to admit, when I first started, I was pleasantly surprised that it just worked. I love it when things just work. Next up, we'll conclude this section by showing how you have some options for other template and CSS preprocessors. So far, we've learned about the key tools available to you on a new Express.js app, namely the Jade template engine and the Stylus CSS preprocessor. One last thing you need to know is that you have a lot of choices when building your apps. In this series, we're using Jade instead of plain old HTML. Jade is a template engine. It takes a markup language, combines it with some data from your application, and then produces HTML or some other format. There are a lot of template engines out there, and they provide a vast array of benefits. I want to mention two that are particularly heavily used by Node.js developers. Mustache is named as such because it uses the curly braces to denote special tags. If you turn your head sideways, it looks like a mustache, kind of. One of the amazing things about Mustache is that you can use it for many different programming languages: JavaScript, Java, C, Python, Perl, and many more. Mustache takes plain HTML and mixes in the mustache tags to do things like show data, provide if statements, or loop over lists. Handlebars.js uses the exact same syntax as Mustache and adds a few things. It is a superset of Mustache. Unlike Mustache, it is built primarily for JavaScript. You'll find it is a little bit more friendly to Node.js developers. One interesting thing is that it works both server-side and client-side, so you can render the same templates in either environment. I'm not going to go into depth into the templates, but just encourage you to go check it out. If you prefer to work with HTML rather than Jade, Handlebars.js is worth considering. The syntax is mostly HTML with a few extra tags sprinkled in. To use a different template engine, you first have to install it. Add the package you want to your package.json. For handlebars, you use express-handlebars. Then you run npm install from your project root to have it installed. Once that's done, you can change the view engine in app.js and then make sure to name your views with a .handlebars extension. When you run express-help, you'll see that you have the option to set your project up with one of several template engines. These are not kept up to date, so if you want to use one of these engines, go to the NPM website and find the documentation for the updated module and use it to install the engine you want. Let's discuss CSS options while we're at it. Stylus is a CSS preprocessor, and while it comes with Express.js and is commonly used in beginner tutorials, it looks like Less and Sass are growing in popularity at the expense of Stylus. All three do very similar things, though, so learning one will help you even if you switch later on. One thing that Stylus has is a syntax that is very harmonious with Jade, so it makes a great match. Sass is an excellent preprocessor option that looks a lot like CSS. The first things you'll notice about it is that there are variables that begin with $signs, and that you can nest rules inside of other rules. For example, creating a curly brace li color :red will produce a CS rule a li curly brace color red. This can be incredibly convenient. Sass gained a lot of popularity because it was bundled with Ruby on Rails since version 3.1, which makes sense because Sass was created with Ruby. Like Stylus, it offers mix-ins and some built-in functions to make common CSS tasks simpler. Another popular CSS preprocessor is Less. One of the first things you'll notice about Less is that it's very difficult to distinguish it from Sass. It is not hard to convert a Sass file into a Less file or vice versa. The syntax is slightly different, but the biggest difference is that less is built with JavaScript. When it was first released, it ran in the browser, but these days most people use it with Node.js. Unlike the template engines, it is safe to choose your preprocessor from the command line when you create your project. When we create our project, we used the CSS Stylus. If you want to use less, you'd instead use --CSS less. Sass is a little different because we'll use --CSS compass is actually Sass plus some common helpers. We'll actually gain many of the benefits of Compass by using Bootstrap. Speaking of which, Bootstrap comes in 3 versions: a CSS version, a Sass version, and a less version. In this video, we talked about how there are a lot of options available to you as an Express developer. You can choose from numerous template engines as well as several popular CSS preprocessors. There's an old saying, variety is the spice of life. I guess that Express.js is full of flavor. This wraps up section 2. In the next section, we'll start planning our application and begin writing some code. In this section, we're going to plan our application. We'll be building a small application that will allow us to demonstrate all of the most important aspects of common Node.js web apps. Because of this, we shouldn't expect any changing requirements coming our way. I think it's safe to plan out the whole application. Express.js works well in agile projects where requirements are changing. Utilizing test-driven development and modular code, which are both explained later in this series, will help you respond quickly when you have to make changes. A simple database application usually does 4 things: create, read, update, and delete information. Developers affectionately refer to these common operations as CRUD. In our case, we'll be making a simple content manager application because it will allow us to exercise all of these operations as well as introduce the most common challenges that need to be addressed in Node.js. We'll be able to view a list of contacts, add new contacts, delete existing contacts, view details about a contact, and update the information about the contact. As you can imagine, you don't want some stranger deleting entries from your contact list, or for that matter, you may not want them to see your list at all. Therefore, we'll need to start out by requiring people to log in or create an account. The most popular tool for doing this in Express apps is Passport.js. We can configure it to allow login via social media, such as Twitter or Facebook, single sign-on providers such as GitHub and OpenID, or you can use it to create a local username and password system. In our case, we'll allow people to log in using either Facebook or Twitter. Of course, if we're creating a database of contacts, we'll need to store them in a database. Node.js and Express support many different kinds of databases, including traditional relational databases, such as MySQL, key-value databases, such as Redis, and non-relational databases, such as Mongo. Don't worry if I didn't mention the database you prefer, there are very likely support for it. In this app, we'll be using MongoDB. There's a superb library for accessing Mongo called Mongoose.js. In real-world applications, you should be using automated testing. In my experience, over half the battle of testing is getting your first test to pass. Once you do that, it gets easier. Therefore, we'll help you get past that first big hurdle as we develop our application by setting up our project with a unit test framework. We'll be using the Karma test runner, the Mocha.js test framework, and the Chai assertion library. We'll also be utilizing the supertest helper utility and the Sign-on.js mocking library. Wow, that's a lot of tools. But they're simpler stacks. But there are some great reasons to use these tools, and we'll get into that more during section 5. One of the most popular articles on my website was about setting up Node.js the right way. It explains a set of tools that help you lay out your Node.js app to improve your productivity as a developer. In addition to the tools I mentioned regarding testing, we're going to use a tool called Supervisor. The last thing we'll need to plan out is our URL structure. We're going to follow a RESTful URL convention. The main goal of our application is to view contacts, so when we visit the URL /contacts, then we should see the list of all the contacts visible to us. If we want to make a new contact, we'll do a post request. In other words, a form submission to contacts. If we want to view an individual contact, we'll view the URL /contacts /contact ID. If we want to edit a contact, we'll make a put or post request to contacts /contact ID. And if we want to delete a contact, we'll make a delete request to /contacts /contact ID. In this section, we discussed what our contacts application will be able to do. We've also covered the different libraries we'll use to make our development easier, and we've also planned out the URLs that our application will expose. Next up, we'll install the modules we need. Now that we know our goals, let's install our modules. The modules we use in our Node.js project is referenced in the package.json file. We've seen it before and we'll definitely see it again in this project. We need to group our modules into 2 categories. Those we'll need to run our app and those that we need in order to develop the app. Then we can list these separately in our package.json. Let's start out with the dev dependencies. Running automated tests is a developer activity, so we'll want all of the tools related to testing as a dev dependency. That means we'll want Karma, Mocha, Chai, Supertest, and Signon, all as dev dependencies. A database is required to use the app, so we'll add Mongoose library to our dependencies. We'll also want authentication, so we'll add Passenger module there. The other dependencies should be there already, for example, Express.js. You'll notice that each module has a version number. This is optional. You can just put an asterisk in there if you like, and you'll get the latest production version. Sometimes that's good and sometimes it's bad. For example, let's say you develop with version 1 of a module and then a few months later version 2 comes out and a lot has changed. When you do an update, your application can break. Generally speaking, in a version number such as 2.10.3, the 2 is the major version. It signifies dramatic, probably incompatible changes to a module. The second number, the 10 in this case, is a minor version number, which typically signifies new features. But a generally compatible release in the last number is the revision number. In this case, a 3. Typically, when this number is incremented, it will indicate that a bug was fixed, but the application should be compatible. In your package.json, you can list an exact version, or you can chop off any of the numbers to the right of a period and add an asterisk to mean the latest version that matches the left side. For example, you could say that you want the latest 2.10 release by specifying 2.10.*, or you could say that any version 2 module will work with 2.*. There's a lot you can do with version numbers. For example, you can say the latest version before version 3. To learn more, check out the documentation for semver. In this case, if you want to follow the tutorial and have high confidence things are going to work for you as they did for me, use the same version numbers I'm using. Save your changes and return to your terminal. Run npm install and let it go. As you see the list of modules, you may wonder to yourself how I know about all of these and why I chose them. Something I suggest you do from time to time, maybe once per week, is visit the npmjs.org website. On the homepage, you'll see they have some top 10 lists. One list that changes somewhat slowly is the most starred list. This list essentially reflects the popular opinion of Node.js developers. You should take a little time to get familiar with each of these. Another list is the most depended upon. You may not directly use many of these modules, but they are probably in your app, available for you to use. Getting an understanding of these can help you unlock hidden power. The recently updated list changes very fast, and browsing this helps you discover new modules. Some of these aren't very useful, some are. The last list is the most prolific module developers. These are developers who are making major contributions to the modules referenced in the NPM database. In this video, we listed out what modules we'll be using. I explained dev dependencies and how version numbering works, and we installed the modules. Next, we'll actually write some code by configuring our URLs. By this point, you're probably ready to write some code. We have our modules installed. We've tested our application. Now we're going to stub out the URLs. Right now, we have a homepage URL. We're also going to need the CRUD endpoints. Eventually, we're going to have authentication, but we'll deal with that more in section 7. As we know from our test, the static assets and homepage URLs are already defined. There's no need to do anything to get that functionality. As a matter of fact, there's one route defined that we're not going to need, and that's the user's route. Let's delete that line from app.js, and we can also delete the requires statement. And since the route's users.js file is now dead, let's delete it as well. Let's ensure that everything is still working, so open up your terminal and run npm start to launch your app. Then visit http localhost 3000 to view the homepage. It works! The next thing we'll do is make the context route. Let's double check to ensure that it's not already working. You should get a not found error. We're going to keep our code somewhat separate, so let's make a new file called contacts.js and add our first route to it. We need to start out with 2 requires to bring in necessary modules. You can copy these 2 from routes index.js. Now we need to make our context route. At this point, I'm going to confuse you just a little. We know that all the routes we're going to make will begin with contacts. There will be /contacts and /contacts contact ID. Because the first part is the same, we won't specify that here. We'll just do the parts that are different. So our first route, the context route, needs to be specified with just a / as the URL. This route will pertain to just the get method. We'll make an anonymous function that takes rec and res, and for now we'll just respond with it worked. Since this is a public method, we'll export this route. One of the things I've always found confusing is that we write the code for our routes in routes /star.js, but they don't work until they are .used in app.js. This allows you to group the definitions to some URLs into separate files. Hopefully, after we work through this, it will start to make sense. Let's revisit app.js. Back where we import our index routes, we should import our contacts routes. So let's require that now. Then when we app.use/, we should also app.use contacts as well. Save your changes, and now let's refresh our browser to see it work. But wait, it didn't work. We still have the not found error. The reason why is because server-side JavaScript does not get reevaluated when you save changes. This is a very annoying aspect to Express.js, and it is for this reason that I'd like us to install Supervisor. You could hit Ctrl-C in your terminal and then run npm start to relaunch your app, but Supervisor essentially will do this for us. You'll see here in the script section there's a start script, and it simply uses Node to execute the bin/www script. Let's change that. Here we'll add Supervisor to our dependencies and do an npm install. This will not install Supervisor system-wide. Instead, it'll put it in the node modules.bin folder. If we look, sure enough, there is Supervisor. So instead of using npm bin www, let's add Supervisor. Make sure to save your changes. Run npm start and you should see the usual results with just a few extra bits of information. Since we manually restarted the app after installing Supervisor, we should be able to go back to our browser and reload the page and see it worked. Okay, now that's working. Let's add the post route for creating new contacts. Since our first route uses router.get, you might have guessed that we can now use router.post. In every other aspect, this route can match the last one. When you save your changes, if you go back to the terminal, you should see that Supervisor reloaded itself automatically. Sometimes when you make a change and go to your browser to refresh, you'll get an error because you reloaded faster than Supervisor did. Just count to 3 and then refresh again. We're going to use a little bit of a shortcut to make our next set of routes. We'll say router.route and we'll list the URLs /contact_ID. It won't take an anonymous function. Instead, we're going to chain some additional methods onto this function call. On a new line, create the .all method. This is special because it will always run regardless of if we're using get, post, or another method. You don't need a .all method, but we'll be using it to create a local variable for the contact ID. Notice the URL has :contact_ID. This will be a parameter that we can use in all of our routes. We'll grab that param and stash it in a local contact ID variable. .all needs to take an anonymous function with 3 parameters, rec and res as above. But also next is a function that we'll call when we're done processing. It's very important to call this or the browser will never finish loading the page when accessing this URL. After we've grabbed contact ID, we'll call next, and then we'll chain on a .get function. In here, just send back a string like we did in our previous routes, but let's include the ID so that we know it's working. We'll also chain the .post method as well. When we want to edit a contact, we'll use the put method, so we'll also need a .put handler. In this case, we'll just respond like we did with get. Lastly, we'll need our delete route. As with the last two, we just chain on a new method that matches the HTTP verb. So create your .delete route and send back a helpful message. Save your changes and let's review in the browser. In this case, just go to contacts/1 and we should see our message saying, hello for contact 1. Notice that since we used the send method, this page is very plain. It didn't use our Jade template. We'd have to use res.render to get that. In the next section, we'll be working on making it look nice. This is optional, but if you want an easy way to test the verbs other than get, we can use a command line app called curl. Keep Express running and open a new terminal. The command we need is curl-X verb URL. Let's start with a post to contacts/1. It worked. Let's also test put. Now we can test delete. In each case, you can see it worked. If we tried to do a delete request on a URL that didn't work, for example, if we do a delete to just our contacts URL, we'll see we get a 404 error. You'll notice that the first time we created a route in contacts, we had to update app.js, but we didn't need to update it each time we created a new path. That's because all of the routes were under the contacts URL, and therefore Express only needs us to specify them that first time. In this video, we created our routes and tested them. Right now, they do practically nothing, but in the next section, we'll start creating our HTML, and we'll begin to see the functionality of our app take shape. We now have a pretty clear idea of what we're going to do and what modules are going to help us. In this section, we're going to build the HTML of the application. In this video, we'll set up plain HTML pages that have no dynamic data. Then we'll be able to click through the forms and see how our application would look. Later on, we'll add some dynamic data to these pages. For now, every time you reload the page, and no matter what you enter into the form, we'll always have the same information. This video isn't about graphic design, though with the help of the Bootstrap library, we'll be able to create a nice looking application. In order to use Bootstrap in our project, we need to make sure to import the CSS files on our stylus.style file. Make sure to download the CSS version of Bootstrap, and you'll want the Bootstrap and Bootstrap-theme files in your style sheets directory. Then we can use them in our Stylus file. First, we'll have to create a page that shows all of our contacts. We'll call it list.jade and put it in the views folder. The main content area of this page is a table of people in our address book. We'll add a headline to provide context, and here's a short paragraph that no one will ever read, explaining what they can do on this page. Our table of data has a column of checkboxes so that people can delete multiple lines at once. We'll need a delete button here at the top of the table, and while we're at it, we need a button to add new contacts. Let's keep using the Bootstrap buttons. Notice that I put a pipe character here on a blank line. There are actually two spaces. The pipe character in Jade means to continue on with the same tag, in this case the P tag. If that wasn't there, the two buttons would be squished side by side. Now we need a 4-column table. The first row is a header row with columns for action, name, nickname, and email address. To keep that first column small, we won't put the word action in the header row for the checkboxes. Now for table rows. We'll just use some dummy data until we start using a database later in the series. That should do it for this page. Now let's create a template for the add page. We'll call this one add.jade. Not very original, eh? This one is going to be pretty simple. We're going to use the grid system to create a column that fills up half the page. Then inside that column we need a form that submits the data using the HTTP post method to our view that we created in the last section. In this form we'll need a field for email address, full name, job/position, and nickname. Then we'll want an add user button. That's it for this page. Let's create another template for the edit page. We'll call it edit.jade. Now when we look at this, we'll notice that it has everything the add page has and more. The only real difference in the parts that are similar is the button that says update user. I firmly believe in dry, D-R-Y, which means don't repeat yourself. So let's go back to add.jade real quick and separate out the parts that are common. We'll grab everything inside the form field except the submit button. We'll put this in another file called editform.jade. Then we'll include it into the add.jade file. Now we can do the same in edit.jade. Here we'll add the editform.jade. Don't worry for now, the fields are blank. We'll fix that in the third video of this section. But wait, there's more. The edit form also includes another form for adding notes and a running list of the existing notes. It's not necessary, but I'm going to actually create a separate form for just this field. We'll add a label saying notes and a few dummy notes. Then we'll use the add note label, the text area, and then the add note button. Now we need to go back to our contacts route and change the .get method for the list to display the Jade template. This is easy. We just change res.send to res.render. Render takes two parameters. The first is the name of the template. In this case, the template is list.jade. We can leave the .jade off because Express knows that part. The second is an object of variables that we need to pass through. For now, just send in an empty object. We also need to create a route for add that renders the add template, and then we'll update the get method for /contact_ID to render the edit template. Let's also go to the home page for the site and add a button to our contacts page just to make testing easier. Make sure you started your server, and now we can test it in the browser. Visit http://localhost:3000 and click our button. Sure enough, there's our list. Each list item is clickable. If we click it, we can see the edit form. Let's go back now and we'll click the add button to see our add form. There we are, it all looks good. In this video, we created the Jade templates to show the HTML for our forms. Then we updated our routes to render the templates, then viewed them working in our browser. In the next video, we're going to discuss some bad habits to avoid when creating templates. It feels good to see our app coming to life. If you're like me, it's hard to not dive into the deep end and start building things. Don't worry, soon we'll be doing more code and adding more content. First, I want to show you a problem that is easy to run into. We have a very powerful template engine at our disposal. It can do some amazing things. However, just because it can do rich programming-like functions doesn't mean that we should do it with a template. Let's define logic as code that makes a decision and acts upon it. We're using Jade as our template engine. In the classic MVC architecture, that would be the V, or view. The view is responsible for showing the part of the application that people see and interact with. Try to think about the smallest amount of code you can use to achieve that, and that is probably as complicated as our template should be. You see, when we mix logic and presentation, our code looks messy and it's hard to maintain. The concept of separation of concerns states that our code has different sections, and each section should focus on one particular job and do it well. Jade templates take dynamic data and convert it to HTML. Routes make complicated decisions and choose which template to show. Okay, that really is my big warning. I've seen some template engines and languages that encourage putting complicated logic into the templates. I've worked on projects where this was mandated. It makes your life harder in the long run. Resist that urge and keep your logic in the route or in a separate module. Now, on to the next video, where we'll start displaying dynamic data with Jade. We now have a working HTML site, but all the information is hard-coded. It's not really an app yet. It's time we fix this. We don't have a database yet, but that's fine. We'll start out by creating an in-memory database using JavaScript objects. At the top of this file, we're going to start by requiring the underscore library. This will help us simplify some of our code. Of course, we haven't actually installed the underscore library, so let's do that before we forget. Here's a nice trick. From the command line, type npm install underscore -- save to install it and automatically add it to the dependencies in package.json all at once. After the requires, we'll create an array of objects. Each object has an ID field to uniquely identify each contact. There's a field for the name, a field for the job title, a field for the nickname, and the email address. I'm also including two helper functions to get us by until we have a real database. The first will look up a contact by its ID and return it. The second will find the last ID used in the database and return it, which will be useful when we need to add records. Now we'll want to update our view that lists all the contacts. Instead of sending an empty object, we're going to add one field. It will be called contacts, and it will be the array of contacts. The post method for creating a new contact needs to be updated. The first thing we need to do is use our findMaxID function to get the highest contact ID, and then we'll add 1 to it and use it as our new contact's ID. We'll then get the data from the form, which will be accessible in rec.body variables. Here's rec.body.fullname, job, nickname, and email. These are all stored in a new object which we then push onto the contacts array. Note that after accepting the form submission, we can either res.send a confirmation message, which we'll do for now so that we can see that it's working, or we can res.redirect. In many cases, res.redirect is more user-friendly for our end users. The get method for our add route can remain almost the same. We don't need to send any dynamic data for that to work, but in order to be compatible with the edit form, we will add an empty object called contact in our context object. We're also going to update the .all method for our router.route so that it does a lookup contact with a contact ID and keep it as a local variable. Every method in this route needs that, so we'll avoid code duplication and do it once in the .all. Next comes the .get method, which shows the edit form. The only change here is to include the contact in our context object. The .post method will be for adding notes. In order to add this functionality, we'll need to ensure this contact object has a notes array. Then we'll push a new note onto the array. A note is an object with two properties: created, which is the date it was created, and the note, which we get from the form. Again, we have the option to redirect, but while we're testing, we'll stick with res.send. The last function we'll update this time is the .put method. In this case, we just have to update the contact's properties with those from the form, and then we'll res.send the confirmation message. Now let's go to our Jade file for the list and see what it takes to show the dynamic content. First, we need to check to see if we have anything to loop over, so we'll check that the contacts variable has a length. If we don't, we'll display a message telling people to use the add button. It will be a table row that spans all 4 columns. If we do have contacts, then let's display all the records. We'll use the each statement in Jade to do this. For each item in the contacts list, we'll temporarily store the value in a variable called contact. When we're only using the dynamic data in the field, we just use the variable after the equal sign, like in the ID attribute for the checkbox. If we're going to mix static and dynamic content like we do in the href attribute for the link, we use the hash curly bracket syntax. We'll use that syntax for the name, job, nickname, and email fields. Let's test it. Refresh the page in your browser and voila, we now have dynamic data. Let's test our code to add records. We'll hit the add button and fill in all the data, and then submit the form. Here's our helpful message. We need to use the back button to return to our list and then refresh the page. Here I am in the list. Yay! Before we can use the edit form, we'll need to make some more changes to the Jade files. We'll need to open editform.jade and add values for the form fields. Now we'll go to the edit.jade file and change the notes. See how I'm using the if statement to see if the contact has notes? If so, then I'll loop over it. Also note how the action for both forms has been updated to include the contact ID. Next, let's view the edit form back in the browser. Notice how the fields are pre-populated with values to edit. Also notice that our dummy notes are gone. Let's add a note. After we submit, we hit the back button and refresh to see our changes. It worked. Next, we'll test the edit functionality. We'll just change the job field. When we submit, note the helpful message. It says a note was added. What happened? When we hit back and refresh, we see a new note, but there's no note. When we look at the Jade file, we see the problem. The form is using post, but the route expects a put. However, this presents a new issue. Browsers only support the put method if we're using Ajax, and we're not using Ajax. If we change the message to put, the browser wouldn't understand it and just assume we meant get. The way around this is with an Express helper called method override. As of Express version 4, this is no longer included by default, so we need to switch back to our terminal and npm install method override and ensure we use -- save. Now in app.js we need to add 2 lines, one to require the module, which we can do right after the body parser middleware, and then to activate it, which we'll do right after the body parser is activated. Note that it takes one parameter. This is a get variable that specifies the method. Note that if we do use Ajax to send a put request, the method override middleware won't interfere. Express will behave just as you'd expect. Back to the edit.jade file. We'll go to the edit form, and after the ID, add !_method equals put inside the quotes. Now save and refresh in the browser. When we update the record, it gives us the proper message, and when we refresh the list, we see the updated job title. If we check out the console, we'll see that the logging listed it as a put request. I'd like to cover one more thing while we're in here, and that's the code to delete items from the list. For this code to work as intended, we'll need to use client-side JavaScript and Ajax. For that reason, I've downloaded jQuery and created an additional JavaScript file which I've called main.js. I've added references to them in the layout.jade file here. In a nutshell, how this works is it listens for the delete button to be clicked. When it does, it gets a list of the checkboxes that are checked, and for each one, it does an HTTP delete request using Ajax. That means if I check 3, there will be 3 Ajax requests made. If the .delete handler on the route succeeds, the TR will be removed from the table. The server-side code currently always returns a successful response. Therefore, when I refresh the page, the items come back. Now we have a fully functional single-user CRUD app. We can view, add, edit, and delete entries. However, we have a serious limitation because we're using an in-memory database. The downside of this is that when we stop Node.js and start it again, or even if we just edit the JS files, which triggers a stop and restart, all of our changes are lost. We'll overcome this by using MongoDB, but before we get too much further, let's talk about testing our app in the next section. Modern web applications, even the simple ones we're building in this video series, are very complex and made up of multiple components. There are a lot of variables and many things can go wrong. There are as few things as uncomfortable as having a boss or customer call you to tell you about a problem with a web app you've built. Nothing I can teach you will eliminate all errors and problems. However, we can use a rigorous test plan that exercises all aspects of our app to look for ways that it might break. In my first development job, our test plan was a lengthy manual. It included a series of tests that needed to be performed every time we made a change. Anytime we added a new feature, a button, or a page, we added a new document to the test plan. Then, before we gave our final approval to release our changes, we were supposed to go through the entire test plan, step by step. Go to this page, click this button, enter this value, click submit, check that field 2 is highlighted as a required field, enter this value into field 2, click submit, ensure that the entry was saved to the database, and on. I say supposed to because, quite honestly, these test steps were boring. Nobody wanted to do them. They were so repetitive and they took so long, and frankly, in most cases, the changes we were making were low risk and in our minds unlikely to cause a problem. Inevitably, once in a while, we did cause a problem, and the boss would ask why it didn't get noticed with the test plan. The answer is simple, you know it as well as I do. Humans don't like boring tasks like this. It is for this reason that we have computers, to do these boring repetitive tasks. Modern tools, which we'll explore in the next video, allow us to easily automate all of these tests. It takes very little time to write the tests, and in most cases, our tests can run in 1 or 2 seconds, often faster. It's quite common for developers to set their computer to run tests every time they hit the save button. If they've made a change that causes a problem, they'll know it instantly, while the change is fresh in their mind, and then fix it right away. This greatly lowers the cost of maintaining our app. If you are disciplined and do this for your entire app, start to end, then you get something many developers wish they had: peace of mind. You don't have to hold your breath when you publish an app hoping nothing breaks. This also gives you the freedom to go back and clean up your code without fear that you're breaking something. We are always learning new things, And if you're making some changes to an older module, and now know a better way to code something, you can change it. Run the test, and if everything passes, rest easy, then now your code is a little better than it was before. I wish I could take the time to teach you all I know on this subject, but it is a big enough topic that we could spend the whole series just on testing. However, in my experience, I've found that there are two big hurdles to adopting an automated test plan on your project. The first is getting your project configured so that you can write and run tests successfully. The second is the actual job of writing the tests. Many times I've seen people get stuck on the first step and never get to move on to the fun part of step 2. In the next 3 videos, I'll explain the different strategies for testing, and we'll set up our project to run automated tests. Once we get this working, you'll be ready to start incorporating these tools into your work. There are different ways to write your tests. Some test small parts of your code base at once, others test large portions of your code base. Let's compare the options that are available. Selenium is a popular full-stack testing solution. It takes control of your web browser and then interacts with your application in the same way a user would. It's considered a full-stack testing tool because it tests the entire website, from the client-side JavaScript, the HTML rendering, the network protocol, the server-side code, and any extra services such as databases used by your server-side components. Selenium is available under a free license. It provides a tool to record interactions with the browser and then can run them again anytime you like. This has helped make it popular with testers who don't have a programming background. Selenium is also useful for programmers because it can be controlled using code. I've used tools such as Protractor and SST that allow us to write code that controls Selenium, which in turn launches a browser and performs tests. Protractor is a JavaScript library, and SST is a Python module. Whether we're using the recording feature or code to control Selenium, it is still a full-stack testing tool. There are serious downsides to full-stack testing, and for that reason, we won't be focusing on them. One big problem is the time it takes to both create and run your tests. A test suite will typically take at least 10 seconds to run, and more likely it will be several minutes. This is fantastic compared to the manual testing from ages past, but even at 10 seconds, it's slow enough that you won't do it while you're coding. It's too big of an interruption. Another problem with full-stack testing is that there is an opportunity for errors outside of you, the programmer's control. For example, if your web application includes Facebook's Open Graph.js library or Google Analytics, and there is a network connection problem, it can cause your Selenium test to fail. Or there potentially could be a genuine code error, but the only manifestation of that might be a subtle UI glitch. Selenium's log will not make it clear where in your code you have a problem. This is why we write unit tests or microtests. These are tests that cover a small bit of code or a small unit of code. For example, if you have a helper function that formats dates from UTC time to something like 2 minutes ago, then you can write a series of tests that will give it different forms of input and ensure that whatever it returns matches what is expected. You might have 10 tests for this one function, and when you run the test, the whole suite can easily finish in under 1 second. When I learned this style of testing, I was taught the term unit test, but I've since learned that sometimes microtest is a more valid name. It really boils down to how you think about your code and your test suite. Do you write tests for every function and method, i.e. unit tests? Or do you write tests for only your public API? In either case, I wouldn't worry about the semantics too much. I think that microtest is more accurate, but most people I know just call them unit tests, so use whatever term works best. Here are the hallmarks of a microtest. It runs fast. It does not run in the context of your application. Instead, it runs in a special environment where the global scope is controlled, and it is automated. That brings us to the terms TDD and BDD. TDD, or test-driven development, is a concept where you write the test for your code before you write the code. For example, let's say you're going to write a function that formats dates. Before you write the function, you write the test that calls format_date. The test fails, of course, so then you write just enough code to make the test pass. Then you enhance your test to check the next bit of functionality, run it, watch it fail, and then write just enough code to make the test pass. Once you've done this enough times, you can make your code cleaner and smarter, so you refactor your code, ensuring that your tests still pass. The benefit of this is that if you only ever write a line of code to make a test pass, then you'll never have to worry about some of the code you've written being untested. BDD, or behavior-driven development, is an evolution of TDD that prescribes a particular syntax that makes your test a little more readable. Both work equally well. The tools I'll help you with in the next video will let you choose either style, so you can decide which you like best. There's one last thing I want to discuss related to testing, and that is a tool that is halfway between the microtest and the full test stack. Sadly, I don't know of any catchy name for this kind of tool, though in some circles it's called a test client. In our Node.js app, it would test the full server-side stack, including middleware. It does not launch your Node.js app. Instead, it merely runs your code in the same way Node.js would, but with some hooks for testing. Likewise, it won't render your app and send it to a browser, but your app won't know the difference. For this reason, it gains the speed benefit of microtesting, but keeps the disadvantage associated with testing multiple components at once. However, it can make some of the harder to test parts of your application testable. For example, routes and middleware, so it's very useful. Now that we've covered the testing landscape by discussing the differences between full stack, microtesting, and our test client, let's set up our project in the next video. We've talked about why automated tests are good and different strategies for actually doing our tests. Now let's begin. One of the most difficult and frustrating parts of doing testing is getting our tools working. There are many books, videos, and tutorials on writing tests, but they do you no good if you can't actually get the test runner working for your project. Let's open package.json, and you'll see our dev dependencies list our testing tools. We have Karma, which is a test runner for client-side code, Mocha, which is our test framework, and Chai, which is our assertion library. If this doesn't make any sense yet, don't worry, it may never make sense, but it will still work. We've also added Sign-On, which is a mocking library, and Supertest will be our test client, which we mentioned in the last section will help us test our middleware and routes. While we have package.json open, we need to add a line to it. In the script section, we have only one item listed, start. That allows us to start the server by typing npm start. There are a few preset list of actions that you can specify, such as start. Another one is test. Add a comma to the end of that line, and let's make a new entry in that object for test, and we'll use this path. Note that we also add the -u TDD option. This means that we're using the TDD, also known as JUnit style assertions on our project. There are also BDD and expect style assertions available. If we run npm test right now, we get an error because we don't have a folder for our tests. So in the root of our project, create an empty folder called tests. Now, in your terminal, run npm test. You should see a message like this that says 0 tests passing. Notice it's green, and green is good. We have no passing tests, but we also have no failing tests. If you're astute, you may notice that we're calling Mocha, not Karma. Karma is not needed yet because we're testing our Node.js code. We'll use it in the next section when we discuss client-side tests. In the test folder, we need to create a file. It doesn't matter what the name is as long as it has a .js extension. We'll create a file called demo.js. What happens next varies depending on the assertion style. We're using the TDD/expect style. The first line of the file will import chai. The second line will define assert as chai.assert. Our tests are grouped into suites using the describe function. I will typically put my suites into a file with the same name as the module it will be loading. Therefore, I will only have one describe function in a file. You can put a describe inside of a describe to help you organize your tests better if you like. This can be handy for organizing your output. Now that we've got a suite, let's create our first test. Call the it method, where the first parameter is a label and the second parameter is a function. The label customarily begins with the word should to describe what the test does. Here we'll call an assertion to see if x equals 1. Outside of this function, but inside of the describe, we'll create a variable x and set it to 0. Now save your file and run npm test in your terminal. Yay, we get an error, and we got it fast. Let's create a before each function inside our suite. Here we'll increment x by 1. The before each function runs before every test. In this case, we only have one test, so it should run only once. Before the test, incrementing x by 1. Now save and run, and you should see a pass. Let's see a better example of how before each works. Let's create another test method and use the same assert line. Now when you run your test, you should see one pass and one failure, because the before each incremented x to 2 for the second test. After the before each function, let's add an after each function. Here we'll set x back to 0. Now when you run the test, you get 2 passes. Before each sets x to 1, then after each sets x back to 0. Right now, we're only using the assert.equal function. However, there are many assertions. If we look at the documentation for Chai's assert library, you'll see we have things like OK, fail, is null, and more. These can be very helpful. As you start testing more, read through these so you can add them to your tool belt. OK is one of the most versatile because it tests an expression and checks to see if it's truthy. If it is, it passes. This is great, but we're not testing any real code. Sadly, we've not written any real code yet to test. So let's contrive something. Normally you'll require your module, then write a test that calls your module, and checks if things worked as expected. In this case, we'll call Jade. We need to require it, then we'll create a test called Jade render. We'll create a template that is simply the string container. We expect this to get turned into an empty div with ID container. So we'll create a variable expected with that value. Notice that I also added the word hi in here. This is going to break the test. We'll call Jade.render on the template and capture the results. We'll assert that result matches expected, then run the test. It failed. Let's get rid of the word hi. Now when we run it, we see that it worked. In your own project, instead of importing Jade, you'd import your own module. Otherwise, the principle is the same. Now we'll show how to test HTTP requests. At this point, we should probably be creating a new test suite, but we'll be a little sloppy since we're just demoing. At the top of our test, we need to require the supertest library. It is conventional to call it request. We also need to require our app file. Note that we need to use the relative path to our module. Now we create a test called supertest test. This code can be asynchronous, so we need to accept a done parameter to our anonymous function. Now we're going to call request app.get contact. Then on the next line we'll do expect 200 and pass done in as a second parameter. Now save and run the test. We have the freedom to use .get, .post, or whatever we need. If you ever get an error about done not being set, make sure you pass it into your test's anonymous function. This is a technique you'll use for any code that is asynchronous. We now have all the necessary tools to test our Node.js code. Writing good unit tests needs a video series of its own, but now that you've seen it working, you're free to add them to your project as soon as you're ready. We've got one more topic before we wrap up testing. That's testing client-side JavaScript. We'll cover that in the next video. One of the most difficult things I had to overcome when testing my Node.js JavaScript files was that, even though server-side and client-side code is all JavaScript, they each need to be tested separately. The reason for this is because your client-side JavaScript assumes the browser and its DOM will be present. These things don't exist in Node.js. This is where Karma comes in. Karma launches a special test environment, then opens your browser and loads that environment in your browser, runs the tests, then reports the results back to you. By default, Karma is installed in /node_modules karma bin karma. The first thing we should do is initialize our configuration. We do this by running karma with the init option. This will ask us some questions. First, it will ask us what frameworks we want to use. Tab until it says Mocha and press enter. In this project, we won't be using require.js, so you can accept no as the answer. Do we want to capture any browser automatically? Yes, we want to capture Chrome, or you can use a different browser if you prefer. You can actually have your tests run in multiple browsers if you like, but in this case, on the next line, leave it blank and press enter, since we just need to test in one browser. Now we'll have to tell Karma where our source and test files are. Our source files will be in public/javascripts/****.js. We probably don't want our test files being public, so we'll specify a folder in the root of the project called browser-tests, and then tell Karma to also include browser-tests/****.js. Yes, Karma will warn you that there's no files there. That is okay. If you're done entering files, hit enter on a blank line. Now we have the option to exclude files. You can just press enter to leave this blank. Do we want Karma to run tests again automatically if the files change? I don't like this, so I say no, but you can pick whichever you like. At this point, our configuration works. Run Karma with the start command and the --single run option. Now run karma start --single run and see that it pops open your browser, then closes it and reports that it ran 0 tests. We'll make it easier to launch Karma by adding a run configuration in our package.json file. After the test line, add a comma, and then begin a new entry for the scripts object. Call it Karma and use the same command you typed in the terminal. Make sure to add start and --single run. Now type npm run-script karma and you should get the same result. We're not using Chai yet, and at some point you're probably going to want the sign-on mocking library. So let's add support for those. In the karma.conf.js file we created, you'll see frameworks. Only Mocha is listed. Add 2 new elements to this array, Chai and sign-on. Save and exit. Now when you run npm run script karma, you'll get an error about Chai and sign-on not being available. you'll need to run npm install karma-chai space karma-signon space --savedev in order to install these. Now npm run script karma should run without any errors. Let's walk through the same test we created earlier. We'll describe a test suite, set x equal to 0, use it to make a test, and assert equal x comma 1. It should fail. Like before, do before each to increment x, and now our test passes. Create a second test and check if x equals 1. It doesn't. Now set up an after each, and set x back to 0. Now we have 2 passing tests. Yay! Now that we have our tests running, I'm going to leave it up to you to learn how to write great tests. We've set up Karma, Mocha, and Chai, created a Karma config, and created our first test suite, and have seen tests fail and then pass. That ends our session on testing. In our next section, we'll explore the MongoDB database. We're eager to store data, but before we can do that, we need to install MongoDB and its dependencies. As you can imagine, this varies from computer to computer. If you're using a Mac computer and you have installed Homebrew, then you have the easiest installation. Simply type brew install MongoDB. If you use this method, note that MongoDB won't start automatically. I personally like this mode, but it does mean you have to remember to start MongoDB before you use it. You can do so with the command mongod config/user local etc mongod.conf. After you do the installation, this will be shown to you as well as instructions on how to set up your computer to start MongoDB automatically. For everyone else, you want to download the MongoDB installer. This is made slightly complicated because the company that makes MongoDB wants you to buy the enterprise version of MongoDB. So the download link for the free version is not very easy to find, but you can simply visit mongodb.org/downloads for download packages for your computer. If you're using Linux, you may have even more options, however you're on your own. The MongoDB installer includes the server and a simple client. If your Mongo doesn't start automatically, make sure your server is started, and let's do a test. Open a terminal and run the Mongo command. This should show you some helpful messages. You can find a list of commands you can run by typing help. There we see the show DBs command, which will show us our databases. Here we see a DB called admin and a local database. If there was a problem, the most likely culprit is that the MongoDB server didn't start. Type exit to disconnect from the database and return to your terminal. Now you have MongoDB installed, and we can see that it works. Next, we'll configure the database for our application with Mongoose. We have MongoDB working. Now we need to configure our application to use it. In order to do this, we'll use the Mongoose library for Node.js. We've already installed the Mongoose library, so we're well on our way. The main thing we need to do is configure Mongoose. One thing that took a while to sink in with me is that you only need to make the MongoDB connection once per app. Because the connection may not be instantaneous, I put it in the app.js file and start the connection right away. In most cases, by the time your application becomes active, the database connection will be ready. It will probably be the case that you won't be running MongoDB on the same computer that your Node.js runs, except during development. Therefore, we need to create a way to have one configuration that uses a local MongoDB during development and another configuration for production. A common way to do this is to use localhost for development and set an environment variable containing the connection string for production. Therefore, we simply need to check for an environment variable, and if it's present, use it. Otherwise, use localhost. We can do this in one line of code like this. What it does is it sets a variable called MongoURI to the environment variable process.env.mongoURI. And if that does not exist, set it to MongoDB://localhost/testDB. In this case, it uses server name, localhost, and the database name, testDB. Now we need to make the database connection. We first require the Mongoose library, then we run Mongoose connect. We pass in the Mongoose URI connection string, and then set a function that takes 2 parameters, err and res. If error exists, there was a problem, and we'll display it. Otherwise, we'll post a message about the success. The thing to note is the database connections are asynchronous. Therefore, you may see the database connection success or error a few seconds later after everything else is done. Above, I alluded to a potential problem where your application is ready to go before the database connection is live. We won't experience this problem with this app, but I just want to alert you to the potential problem and a solution for that day when it does happen. When the connection is live, Mongoose will fire an open event. The Mongoose documentation gives examples on how to use this. Now, we've set up MongoDB and Mongoose and configured our app to use it. Next, we'll start storing our data in MongoDB. We now have a powerful database at our disposal, and we've configured our connection. Let's put these tools to use. In relational databases, you have a defined structure that is enforced by the database. MongoDB, which is a document-oriented database, is not so strict about structure, but the Mongoose library does give us the ability to define schemas. Schemas are the main way we talk to our database. When we define one, we'll be defining an object that has helper functions to make accessing our data nearly effortless. You can put your database schemas anywhere, but traditionally, we've created a folder called models in the root of the project and store them there. Each model is in a separate file that shares the same name as the schema. In this case, we'll create a file called contact.js. This file will start by requiring Mongoose and then creating a helper shortcut for the schema class. Then we'll create a new instance of schema called contact schema and define what our data looks like. MongoDB will create IDs for us, so we don't need to define them. We'll start by defining the name field, and it is going to be of the type string. Likewise, we'll create job, nickname, and email as strings as well. Notice that up to this point, everything has been singular. That's because this schema represents one contact, which has one name, one email, etc. However, now we'll add notes, which is going to be plural, because this type will actually be an array of notes. Each note will have two fields, a posted date and the note itself. We define these using anonymous object notation as the sole element inside an array. The last thing we need to do is export this. We'll do so using this syntax, which defines the name, in this case, contact, singular with a capital C, and the schema we want to export. That's it. Save the file. Now we have a schema defined. Before we put it to use, we'll talk briefly about the differences you can expect when interacting with MongoDB compared to relational databases. MongoDB is a schemaless, non-relational database. This means there can be some big differences between how you interact with your data in MongoDB compared to databases you've used in the past. The most popular databases of the last 25 years have primarily been relational databases. You use a process called normalization to separate your data into different tables that are linked or related to each other in such a way that very little duplication occurs. For example, you may have a table of contacts and a table of notes, and an ID field indicates which notes are associated with each user. You then create an SQL join query to pull the data out in a way so that you can get all of the notes for a user. In the 90s, object-oriented developing took off and became one of the most popular development styles. You would define objects that have properties. It was sometimes difficult to translate an object into a relational database, so the concept of an object relational mapper, or ORM, was devised. This allowed object-oriented developers to fetch data from the database without worrying how it was stored, modify it, and then save the changes back to the database, all without writing or seeing any SQL. In reality, joins were commonly being done, but the ORM library was doing them, not the developer. At this point, people started to devise new databases that stored data in a way that most closely matched the way it would be used, as an object. These types of databases were document databases and non-relational. MongoDB and Cassandra are two very popular databases used in this way. You create an object and store it in the database. You don't need an ORM because the object is stored in the DB in a way that is similar to how it is used by the developer. There is another class of database in the non-relational database category that is very common, called a key value store. Databases of this type store data in a way very differently from document-based databases. In essence, the database is an array, or more accurately, a hash table. DBase and the various DBM-style databases that have been used since the 80s are examples of key value stores. Some popular modern databases include Memcached and Redis. You look up a field by a name. It could be a number, a string, or some other type of data that can be hashed. And you get back a single value. Usually this value can be anything you want, including a complicated serialized object. They are designed for ultra-fast lookup of data. Memcached, as the name might imply, actually stores data in memory. It's great for data that can be simplified down to a key and a single value. Most types of data don't fit this category though. The database industry is changing, and even more types of databases are emerging and gaining popularity, such as graph databases, for example, Neo4j, and column-oriented databases such as HBase. As I'm describing document-based databases, the number one thing a lot of people wonder is if you can still separate your data into structures like tables. For example, if you have a login system, you may have user objects, and then, using a blog app as an example, you may have many blog posts which were created by a certain user. You can still have relationships like this, but now you have some choice in how they will be stored. You can put them into separate storage containers, sometimes called tables, but MongoDB calls them collections. Or you can do what we did with the notes and make them a child element of the main data type. If you choose the relationship method of storage, which I would certainly do in the case of a blog post app, your application will be responsible for looking up the relationship rather than doing a join and having the database do it for you. It's not hard, and the added flexibility can have a huge benefit. This is a gentle introduction to non-relational databases. Enough talk, let's use our database. Now we'll start using our data with MongoDB. The first thing we need to do is embrace the asynchronous nature of Node.js applications. If you've done much client-side JavaScript work, then you've used asynchronous JavaScript. For example, you may attach some code to a click handler. This code doesn't run until later, when something is clicked. Or you may have used AJAX requests, where you have some code that runs when the AJAX call completes successfully. These are very common patterns in Node.js. Let's start by updating our list page. This is the easiest example to code, but it's not going to be very exciting at first because even though our code is working, we don't have any data in the database yet, so we won't see anything listed. We'll talk to our database using the schema we created, so we have to require that at the top of the file. As a convention, it's typical to use a variable with the first letter capitalized, in this case, contact. Right now, we simply res.render the list template, passing in the contacts. We're not going to make much change to this. What we need to do is query Mongo for a list of contacts. We do this with contact.find. We pass in an anonymous function that takes three parameters, air, contacts, and count. Then we move our res.render line into this function. This is our asynchronous callback. Any code outside of the callback will be executed before the database query completes. Many a time I've been frustrated because my template always rendered with an empty dataset, even though I knew there was data in the database, only to realize that I'd put the code outside of the callback. If there is a database error, the error value will be truthy. Ideally, I check if error is true, and if so, handle the error. I'll do that some other time though. Assuming that our query worked, the results are stored in the local variable contacts, which we're already passing into our template. Save your changes and then refresh your browser. You should see the page now has no contacts. Hopefully, that means it worked, and we have no data in our database. We'll give ourselves the benefit of the doubt, so go ahead and give yourself a pat on the back. Now let's update the code for the post method on the add URL. The first thing we do is initialize a new contact object. We do this by passing an object in with values to populate. We don't have notes yet, so we'll just pass in the name, job, nickname, and email values. We use the rec.param lines just like we did prior to this. The main difference is now we're going to chain onto it a call to the save method. We pass in an anonymous function that accepts air, contact, and count. These parameters are the same as the callback for find. This time, we'll be a little less sloppy and we'll check for the error value. If it exists, we'll say something helpful by including the error message. If the error variable doesn't exist, then it worked, and we can simply redirect to the list page or show a helpful message. Save your changes and switch back to the browser. Now click the Add button. Let's fill out the form and hit Save. Now we should see our newly added record in the list. Yay! Let's go down to the code for our contact routes. First, we'll update the all function with code we want to run on every request. We'll always want the contact, so we'll do a lookup using contact.findById. The first parameter to find by ID is the contact ID we want to search for. Then we pass in the anonymous callback function. Note that I'm using air and C rather than contact. I just want to demonstrate that closures still work the way you'd expect. Inside the callback, I'll set contact to the value of C, and then call my next function. Remember to always call next or your app will appear to load forever. The get function really is pretty simple. We just render sending in the contact. Save and then switch to the browser. Click the contact's name to go to the edit form. The form is populated with our data. Now let's get the editing process working. The put method is where we do the editing. We change the values for the contact, then we do a save. The save also has a callback, and that is where we display our helpful message or do a redirect. Let's make a change to this contact and submit to see what happens. We're shown the helpful message, and once again we see the change was successful. However, we do need to update the note support. Now we need to edit the post method for the contact, since that's where the notes are saved. Remember how the notes were an array? The Mongoose library understands this because of our schema, and supports the array-like functions such as push, so we'll push our note onto the array. Because our schema sets a default value for the date, all we need to do is pass in the note field, like this. Then we do the save just like we did with editing. Let's try adding a note. Sure enough, it works. However, I've never liked the way dates are shown. I'd prefer to say something like 15 minutes ago or 2 weeks ago. We can do this pretty easily with the moment library. Run npm install moment-save to install it on our project and add it as a dependency. Now, in our editor, require moment at the top. Then let's pass it into the render method for the edit form. Now, instead of displaying the date like any other variable, we'll use moment and the .fromNow method. We can make this a little more informative by adding a tooltip with the old data format, just in case you want the exact time. Add an attribute to the DT called title, and add the old format as the value. Now save and refresh. When we mouse over the date, we get a tooltip showing us when it was actually saved. We're almost done. Now we need to just support the delete method. We simply call contact.remove. Then we check for errors and respond with either success or failure. If we checked one box and hit delete, you'll see one AJAX request is made and the record is deleted. If we check multiple, it is possible for cases in which there is a delay in the network for these rows to delete at slightly different times. But usually I'd expect the longest delay to be within 1/2 second, which should be barely noticeable. We now have handled most of the functions that you will need to use when working with MongoDB and Mongoose. Before we end this session, I'd like to mention the superb documentation for Mongoose. It stands out as some of the best documentation I've ever read for an open source project. There is a lot you can do with Mongoose, and as you start to work on more complicated projects, I strongly suggest reading through it. It is filled with excellent examples and practical tips. In our next section, we'll add authentication to our app so that users can log in before using the app. In many apps that use dynamic content, you'll want to restrict access to people who are logged in and possibly customize the view based on that user. For example, we could do a few things with this app. We could require people to register and log in before using it. We could keep separate lists of contacts for each user. We could integrate social media contacts as part of the list, and I'm sure we could come up with even more. Authentication is difficult. We've seen numerous big-name websites in recent years get hacked and accidentally share access to the user database. It's an embarrassment, and it puts your users' personal information from your website and possibly other websites at risk. Every web developer should think carefully before rolling their own authentication. It's not incredibly complicated to create your own authentication system, but it is incredibly complicated to do it well. If you're going to have your own authentication system, you should strongly consider using a module that has many users and developers looking at the code, evaluating the security, and constantly releasing updates. Another situation to consider is relying on third-party authentication providers, for example, social media sites like Twitter and Facebook. Fortunately, the module we'll be using in this section, Passport.js, can do all of the above. Passport is a middleware, code that runs before your routes and views, which deals with authentication for you. It supports more than 140 authentication strategies, including username and password, social media login, OAuth, and OpenID. It is a well-documented open-source library with numerous developers that have been in constant development since 2011. We installed Passport along with our other dependent modules earlier, but there is another step that must be done before we can use it. We need to decide on an authentication strategy. If we search for Passport-related modules, we can see a lot that enable various kinds of authentication. Some allow logging in via external providers. Some allow hooking into a single sign-in provider. There's an LDAP login module, and numerous other options. We're going to start out by using simple local authentication. That means users will register by picking a username and password and then entering it into your site to log in. We're going to use a couple modules to help us. First, we'll need to enable session support, which we'll discuss in more detail during the next video. We'll also install Passport-Local, which enables local database authentication, and Passport-Local-Mongoose, a module that will reduce the amount of code we need for Mongoose-based user profiles. You can add these modules to your package.json, or you can npm install-save them. In your app.js, you'll require express-session and assign it to a variable called session. In older versions of Express, this was built in, but in the recent versions, it has been separated into its own module so that it can be updated on a different schedule. After app.use cookie parser, add a line to initialize the session middleware. I'm passing in 3 strings, a secret which is used to help encrypt sessions and should be kept private and unique for your app. Also, I'm explicitly setting values for resave, true, and save initialized, false. Resave true updates the session on each page view, even if it didn't change. This helps to avoid sessions expiring. Save uninitialized, false, means that sessions aren't stored for brand new sessions that are empty. They won't be stored until something is in them. This cuts down on database traffic for an anonymous user. The next step is to define our user profile model. This is a schema much like the contact schema. We call it account and put it in models, account.js. We are only going to define 2 fields, nickname and birth date. And really, we're only using these as an example for the schema. This app won't use either of those. Note that we don't need to specify a username field or a password. Our helper code does that for us. Now we need to require passport and passport-local back in app.js. After we define our middleware, we'll create a new section for passport. We need to initialize the configuration and then enable session support. We also need to require our module that we recently created. Passport has a callback that needs to be defined, and our passport local Mongoose function will create this for us from the account model. Lastly, for this part, we need to define serialized user and deserialized user functions. These functions store the user's logged in state in the database. Again, the work is mostly being done by our account model. We're going to define routes for logging in, registering, and logging out. We'll keep these in a file called auth.js. This file is not a lot different from our context.js route. We use router.route for the register URL, providing both get and post functions. You'll see that here on the post that we actually register the new account and then check for an error. Right now, we don't do much in the case that there's a problem, but you have a lot of flexibility in what you can do. If it worked, then we log the user in and then redirect to the contacts URL. Then we specify a router.get for /login, which shows the form. I didn't use router.route here because I wanted to show that the .post method has 2 functions that are used. The first is the passport.authenticate function. Right now we're sending in the least amount of parameters, but you can do a lot more, including redirect on failure. The second callback will only be called if the first one succeeds. If it succeeds, it means we successfully logged in and we simply get redirected to the contacts page. The last thing here is the logout function. We call rec.logout and then redirect to the home page. Back in app.js, we wire these routes up under the auth URL. That means we have auth login, auth register, and auth logout. We need to create 2 views and update our index view. The 2 we need to create are the login form and the register form. You'll see that the login form looks a lot like the form we used for adding context. It has only 2 fields, username and password, and it submits to auth login. The register form is exactly the same except for the labels. The index view is still pretty basic. We have an if statement that checks for the user. If it is there, we show the user's name and give them a logout link. If it's not present, which means the user is not logged in, we show 2 links, one to log in and the other to register. Note that as it stands now, users will never exist because we're not passing a user variable into our view. If we open routes index.js, we can fix that quickly. The user information is part of the rec variable, so we'll just add user:rec.user to the context variables. At this point, we have enough to start testing, though we aren't done yet. If you start up MongoDB and then run npm start, hit your browser. You'll see the login and register links. Go ahead and register, then choose a name and password and submit. If it worked, which it should, you'll be redirected to the contacts page. Go back to the home page and you'll see your username listed and a logout link. Go ahead and hit logout, and then log in with the same username. Once again, you're redirected to the contacts page. Go ahead and log out once more. Now, don't log in and don't register. Just hit the link to the contacts page. You'll see it worked even though you're not logged in. We want to fix this, so let's go back to our routes context.js file. In this file, we need to create a custom middleware that gets called on all routes in this file. This is pretty easy. We simply create a router.use callback. and don't define a URL pattern. We pass in rec, res, and next, like usual, and check if the user is logged in. If not, let's redirect back to the login page. If they are, then simply call next to ensure the next matching route is executed. Could it be that simple? Yes, it can. Save your changes and launch the app. Notice that you're logged out. This is because sessions don't survive a server restart. Click on the contacts link and you should get bounced over to the login form. Log in and now you can access the app. That's it for local authentication. The excellent Passport module really makes this easy. Later, we'll use the same module to log in using social media, but first we should talk about sessions, which we'll do in the next video. Sessions are extremely helpful. HTTP is stateless, which means that the server remembers nothing about the last time you visited the site. It's both a blessing and a curse, because this feature has helped the web be as scalable and ubiquitous as it has become. But sometimes you want the server to remember. Sessions are the cure. For example, when you log in, you want the server to remember you on each page view until you log out. A unique ID is created and stored in a database, and on your browser is a cookie. Each time you visit the website, Node.js will retrieve the cookie and use it to look up information in the database. It sounds complicated, and believe me, there is a lot more to this than I'm describing. But fortunately, the session middleware makes it easy on you. If the session middleware is enabled, which we did in the last video, then every rec variable has a session property, which you can both read and modify. The most useless but simplest use of session variables is to keep track of how many times a user visits your homepage. If we go to our index view, we can check if a rec.sessionViews variable exists, and if not, set it to 0. Then, whether it existed or not, we increment it and then pass it through as a context variable called views. In our template, we'll display the total views in a paragraph. Now, when we visit the page, it shows 1, then each time we refresh, it goes up. Stop and restart the dev server and then reload the homepage. Notice that now the variable goes back to 0. This is because we don't have persistent sessions. The default store, if you specify nothing, is called memory store. It uses temporary memory. It's quick and easy, but we have other options. If you don't mind a little complication, Redis store is powerful and fast. However, it requires a Redis server. We don't have one installed, so let's keep looking. Mongo store is another option. We do have a Mongo database, so that makes this a good option for us. In order to use Mongo store, we simply need to install the connect Mongo module, and then in our app.js, we need to require it. Now, lower down, when we app.use session, we'll pass in another option called store. This option usually takes 3 parameters, DB name, server, and port. In our case, we can leave off server and port since they default to standard Mongo on localhost. The DB we're using is called testDB, and we'll specify a new collection called sessions to be created. Save this file and restart the server. Now when we revisit the homepage, the counter goes back to 1, and then when we refresh, it goes up. If we stop the server and restart it, you'll notice that the number just keeps going up as we refresh. It didn't go back to 1. You can store about any JSON serializable object in a session. Putting a database connection in your session is a bad idea, but otherwise, even complicated nested objects should be fine. Now that we have an understanding of sessions, let's go ahead and do some more interesting authentication work using social media in the next video. We have authentication working on our app, but let's get more creative and allow the users to log in with Twitter or Facebook. We've already done a lot of the important work. One thing we have to consider is that we're going to have the ability to log in using multiple systems, in this case, either Facebook or Twitter. If this were a training series on front-end design, we'd create a beautiful drop-down menu with icons for each login service, but instead, we're going to just make a page called auth that has 2 links on it, one for each service. I'm going to just comment out all the routes we wrote in the first auth video, except the logout route. Let's create a new route for index, and all it has to do is render a page I'm calling login options. We need to create this Jade file, and I'm just going to add a headline and 2 links. Now if we go to the middleware we created in contact.js, we'll change the redirect so that instead of going to auth login, it goes to just auth. If you want to save and test, you can, but this is pretty boring so far. The next step involves visiting the Twitter and Facebook dev centers in order to get API keys for our apps. Start by going to https://apps.twitter.com and logging in. Then you'll go to My Applications, and let's create a new application. You need to give it a name, a description, and a website. For now, you can use http://localhost:3000 as the website. Next, agree to the terms and submit the form. Now we're going to go to the details, and there is a tab called Settings. You'll need to check the box that allows this API to be used for Twitter login. All of the other settings can remain the same. Now check the API keys. We need two things, API key and secret. These are essentially passwords, and if you give them to someone, like I'm doing now by showing them on the video, a malicious person can use these keys to masquerade as your app and potentially do things that are deemed abusive and/or violations of the Twitter terms. If you accidentally check your keys into a public repo or show them on a screen recording, you should revoke them by regenerating the keys. Now let's do the same thing for Facebook. Visit https://developers.facebook.com and visit Apps. Create a new app and give it a name and choose a category. There are a lot of settings you can use, but for now we have what we need. Copy the app ID, and then you'll also want the secret. Keep in mind that this site has changed numerous times in the past, and I would not be surprised if it changes again between when I'm recording this and when you view it. Now we need to add the necessary modules. We'll need Passport Facebook and Passport Twitter. Make sure to use --save so that they get added to your package.json when you install. Now in app.js, we'll see where we had the local strategy definition and replace it with the Facebook strategy and Twitter strategy. Note that these have to come after Passport is required. Back in our auth.js file, we need to add a couple of routes for Facebook. These are pretty simple. We need to specify a route for /Facebook that calls the passport.authenticate function with Facebook as an option, and then we need to specify a route for /Facebook/callback, which is where they come back to after logging in. The callback needs two parameters, a success redirect and a failure redirect. In this case, if they succeed, we'll send them to /contacts page, and if they fail, we'll send them back to the authentication page. Now let's do the same for Twitter. The code looks almost exactly the same, so you can just copy and paste it in, changing Facebook to Twitter. Now comes the messy work. The Passport local Mongoose module gave us some helper functions that greatly reduced the amount of code we needed. Furthermore, Passport has a little better support for relational databases than Mongo. It's not a big deal, it just means we have to write a few lines of code. Start by commenting out the existing create strategy line, or you can delete it altogether. Now we need to do a passport.use and pass in the code to create a new Twitter strategy. This strategy takes two parameters. The first is a configuration object that includes the key, secret, and URL that we want Twitter to send people back to. The second is a callback function that needs to check if the user profile exists, and if not, create it. Then call the done function with either an error or the newly created user. I've actually moved the code for the callback to an external module that I've made. We'll discuss how to create modules in section 9, but in a nutshell, I've created a new JS file that has a single function, and the last line exports that function. This function is called find or create profile, and you might not be surprised to learn that it finds an existing profile, or if it doesn't exist, creates a new one. Since this is a Twitter strategy, we're passing in a profile details object, which includes a Twitter ID. We then use our account model to look up the profile that matches that Twitter ID. If it doesn't exist, we create it. We pass in done to be called after the save completes. If the profile does exist, we call done ourselves. Now we're going to do pretty much the same thing for Facebook. This strategy takes two parameters again. The first is a configuration object, and the second is the callback. We're using the same callback, but now we'll be passing in a Facebook profile ID, so when we use our model to find a matching profile, we look for it by the Facebook ID. At this point, our code is done. Now we need to test. Now, confirm that when you try to visit the contacts page, you get bounced over to the auth URL to choose a strategy. We'll start out by clicking the login via Twitter link. You'll see that we briefly pop over to the Twitter page, where I'm already logged in, and then bounced back over to our app. When we visit the homepage, we see that it recognized my Twitter login and shows my username. Let's log out and try logging in via Facebook. Don't blink, this happens so fast you almost don't see it before getting bounced to our app. When we hit the homepage, we'll see that it recognized me as logged in via Facebook. Not so coincidentally, I use the same username for both networks. One last thing to consider. In addition to a login name, you get profile information from social login. You might be overwhelmed to see how much information you get. You can see names, email, friends, interests, city of birth, and more. The code I'm providing you stashes all of this away in MongoDB using the profile field. You can use it or not as you like. You may want to consider your site's privacy policy and choose to discard some of this information and not store it, or you may use it as an opportunity to add better service to your site. Now we have authentication working, both using local passwords or social media authentication. We've also explored how to use sessions. We're getting close to the end of the tutorial, and you should have all the pieces in your arsenal that you need to build some great apps. We're going to move on next to deployment. There comes a point where you'll want to share your app with others. While your app is in development, you might want to test in a production-like environment, share progress with a client or manager, or just get early feedback. You may also want to deploy this app in a production environment for general consumption. There are a lot of options available, including free and low-cost options. There are several things to consider when deploying your app. First, do you have the proper dependencies declared? Second, are your static assets optimized? Third, you'll need MongoDB and other services provisioned in your environment. And lastly, understand the performance requirements you'll need. One of the first things we need to consider as we plan deployment is to understand the difference between development mode and production mode. As far as Node.js is concerned, it boils down to one thing, an environment variable. If we look at the bottom of app.js, we'll see this block that checks for the development environment variable. This is the default, so unless you specify otherwise, you'll be in development mode. An easy way to force yourself into production mode is to set the node.env variable to production. If you're using Linux or Mac OS, you can do this with this command, node.env equals production. When we set up our project, we declared some dependencies as dev dependencies. If you set up your project correctly, your app will work in production without those installed. One way to test is to copy your app to a new folder and use npm install -- production. This will only install the dependencies, not the dev dependencies. Sometimes you'll find that there are things installed that you don't need, which is a minor problem. Other times you'll find that you declared a production dependency as dev, and it won't be installed as needed. Another problem you may run into is that you installed a module, but didn't save it in your package.json. This has happened to me several times. Lastly, it is possible to install packages on your computer globally. That means they are available to every project. I deliberately try to use this as little as possible. You can see what modules are installed this way by using npm ls --g --depth equals 0. One thing you probably don't want to see listed is Express. Express generator is okay though. Your application has static assets such as CSS, JavaScript, fonts, or images. Often these can be optimized to make your site load faster. Multiple CSS files can be combined into one. Multiple JavaScript files can also be combined. Each of these can be minified, and images can be crushed or optimized to make them load faster. In the case of our project, our style sheets are created with a Stylus language, and the middleware we used creates a static CSS file in the public style sheets folder. That's good because it means you really don't have to do anything for your site to work in production. However, it's a good idea to go ahead to combine and minify files. A great tool that can do this is Grunt, which has numerous plugins. The Uglify plugin will take care of your needs for both styles and JavaScript. Note that you don't need to minify your server-side JavaScript, only the files that live in the public folder. Deploying MongoDB can be easy, but getting it done the best way takes a lot of care. If you're expecting a lot of traffic to your website initially, then you want the help of an expert for provisioning. Typically, in high-load scenarios, you will have multiple MongoDB servers in a cluster with different parts of the data stored on different disks, with a backup job taking snapshots hourly or more frequently. Since most new applications start out with little traffic and gradually ramp up, you may not need such a complicated scenario. My smaller apps simply have a single server that runs both Node.js and MongoDB. A next good step is to dedicate a single server to MongoDB. But instead I use MongoHQ, though I've evaluated MongoLab as well. These are services that you subscribe to and you connect to their Mongo servers. You pay based on how much data you need to store and how many queries you need to make. It's a great tool to consider if you have a small development team, and both offer free trials. Understanding your performance needs is important, but invariably it takes a little trial and error. There are a few things you'll definitely want to do. Serve static files with a web server, not Node.js. Reduce the number of modules you need, if it makes sense to do so. Consider what pages will be visited most and expend a little effort to ensure they're fast. Investigate tools that measure website performance to see which areas of your site are slow. For example, Selenium can do this, and the protractor library we mentioned in Section 5 allows you to control it with JavaScript. Once you've done that, you can start getting more detailed. How much memory does your application use while under load? Can your app or parts of it work well when they're cached? Can you use Redis for sessions? Are some of your Mongo queries very likely to return the same information? If so, consider manually caching the results or using a module such as Mongoose Cache. Is it time to move from a small hosting or shared hosting server to a bigger or dedicated server? Or maybe it's time to spread your app across multiple servers. Speaking of scaling to multiple servers, you should plan for this from the beginning. Ideally, your app will get all of its data from a shared source, such as MongoDB or Redis or an API. If you find yourself looking through the documentation for a way to create a global variable that can be shared or stored across page views, you're in a danger zone. Any data that changes should be stored in a database. There are roughly 3 ways to host your app. There's shared hosting, which is common in the world of PHP. Fewer shared hosting providers support Node.js, though there are some, with Webfaction being one of the most trustworthy. I won't be discussing this during this series because these providers tend to all have slightly different, usually well-documented ways to set the app up. There's also the dedicated server or virtual machine method, similar to what you'd do if you bought a server or hosted your app with Amazon or DigitalOcean. In these cases, you have full control and full responsibility for installing the software, managing the OS, and configuring the services. We'll discuss this in part 3 of this section. Lastly, and probably the easiest way, is to use a specialized PaaS cloud provider that offers support for Node.js. The environment for this type of service is quickly changing, but 2 that have stood the test of time so far are Heroku and Microsoft's Azure. We'll be covering Heroku in the next video. This has been the boring, getting ready to deploy conversation, and I know we've covered a lot of information. The important thing to remember is that most apps fall into 2 categories. Those that are very likely going to be high traffic from the onset, in most cases because they're replacing or supplementing an existing service, and those that are starting out from nothing. If you're going to have a high traffic site, then you'll need to take some time to work through these suggestions and expend some effort load testing your deployment scenario. Fortunately, you probably also have the budget and resources to get that done. If you are starting out with no traffic, you'll want to keep an eye on your site to see how bursts of traffic affect you. Deploying to a PaaS service allows you to scale up your environment with the push of a button. In the next video, we'll actually do a test deployment to a PaaS environment. One of the easiest ways to deploy an app is to use a PaaS, which stands for Platform as a Service, specifically tailored for Node.js. There are several out there, but one extremely popular and easy to use service is called Heroku. For apps that get light traffic and have minimal storage requirements, Heroku is free, which makes it great for our test app. If you deploy your app to Heroku and it grows too popular for the free plan, you can adjust their easy-to-use sliders to scale it up, for a fee of course. Heroku works by providing plugins for things such as databases and other services your app may use. In order to get started, you'll need to sign up for a free account on the Heroku.com website. It's quick and easy. At that point, you'll see a dashboard where you can create apps. You can use this dashboard or you can use the command line tools. Let's hold on this for just a moment and get our computer set up. One thing I love about Heroku is their excellent documentation. Click on Docs and then the Getting Started guide for Node.js. Here you'll see a download link for the toolbelt for your platform. This ensures that you have the Heroku command line tool, Git, and Foreman. Install the packages appropriate for your platform and then open a terminal. Start by logging into Heroku by typing Heroku login. For this process to work, your computer will need an SSH public key uploaded to Heroku servers. If you have an SSH key in the common place, it will find it. Otherwise, it will ask you to generate one. The quick summary is that an SSH key allows you to log into external servers without a password. In order to publish our app, we need to update our configuration. First, we need to specify what version of Node to use. I'm using 0.10.x, so we'll open package.json and add an engines object and specify Node version 0.10.x. If you're using a newer version of Node, then use that version instead. You can find out the version using node-v. Next and last, we need to create a proc file, which is a recipe on how to start your app. Just create a file in your project called procfile, capital P, no extension, and in it you just need one line, web:/node bin/www. Save the file. You deploy apps to Heroku using Git. Git is a version control utility, not a deployment tool, so this may surprise you. Essentially, Heroku provides a Git server, and when you push your code to it, the server runs deployment scripts. Once you get used to this, you'll hate anything that requires manual steps. But to get the benefits, you have to use the Git version control utility. This is another topic that can fill a book, so just follow along. You need to initialize a local repository, if you haven't already. Do that with git init. We'll want to add almost everything to the project, but I like to leave out the node_modules folder, so create a file called .getignore. This file name begins with a period. In that file, just put one line, node_modules, and then save and exit. Anything listed in this file will be ignored by Git. Now add all the files by typing git add period. Note the period at the end. That tells Git what files we're going to add, but it doesn't add them yet. We commit them using git commit -m, quotes, adding files, quotes. If you have already used Git on this project, you've probably done this. That's fine. Now we need to create the app on Heroku servers. You can use the website if you want. It's so easy that I won't explain that method. Instead, we'll use a terminal. Simply type Heroku create. This will create a new app and tell you the name it was given. You can change the name later in the web console if you like. Now we get to the exciting part. We publish the app. This is where we push our code to the Heroku servers. We do this by using git push Heroku master. This means use Git to push the code to a server called Heroku and a branch called master. If you've already pushed your code somewhere, this will not interfere because you probably pushed your code to a server called origin. In this case, we'll push to Heroku. You'll see something happening as the code is pushed. The app is published and ready to run, but it's not running yet. In order to do that, we need to allocate one dyno, which essentially is one CPU, to the app. We do that with Heroku ps:/scale space web equals 1. This allocates it 1 unit of work. You can specify other numbers, but you'll quickly get to the point where Heroku will charge you. If you stay at 1, then you're in the free zone. We haven't configured MongoDB yet, so your app won't work properly. MongoDB is an add-on, and one of the providers offers a free tier. Let's add MongoLab support using this. Heroku add-ons:/add MongoLab. MongoLab works by providing a URL to connect to MongoDB as an environment variable. This is not much different than the way we configured MongoDB earlier, except that the variable name is a little different. Open up app.js and see where we specified MongoURI. Change process.env.mongoURI to process.env.mongolab_URI. Leave the last part the same, so that for local development you'll continue to use localhost. Save your file, then run git add app.js, and then git commit -m, quotes, adding MongoLab support, quotes, and then git push Heroku master to republish your app. Until we do a little tweaking, Twitter or Facebook login will not work. It's because we need to specify a different callback URL than localhost. There are 2 ways to accomplish this. One is to hardcode the URL to your Heroku instance, the other is to use environment variables. We should set a variable like this: Heroku config:/set Facebook_callback equals http://mysite.heroku.net. Then in the code, we'll do the same thing we did for the Mongo URL. We'll check for the environment variable, and if set, use it, otherwise default to localhost. Speaking of environment variables, we can force production mode with Heroku config:/set node_env equals production. We're probably already in production mode, but since the variable isn't explicitly set, it may still be in development mode. It's nice to be explicit in this case. The last step is to configure sessions. By default, our session handler will connect to localhost. We can replace db:/testdb with URI:/MongoURI. This will cause it to use the same connection that Mongoose uses. We need to commit and push again, so git add app.js, then git commit -m, quotes, updating sessions and login, end quotes. Then git push Heroku master. Now click around your site and ensure it's working as you'd expect. We should be all set. Yes, there were a lot of steps in this process, but overall, this deployment went pretty easy. We don't have to configure a server, we don't have to worry about operating systems, IP addresses, or anything like that. Furthermore, Heroku has superb documentation. If you like this style of development, but you want to see what other options are available, check out Microsoft Azure, Node.js, and Red Hat OpenShift. In the next video, we'll explore how to deploy your app to your own servers or VPS. If you like to have more control of your services, or you're deploying an application to an internal network, or maybe you have a special configuration that doesn't work well with typical PaaS servers, such as Socket.io, then you'll want to consider deploying your application to a dedicated server or virtual machine. This gives you a lot of flexibility in your configuration at the cost of extra maintenance for the server and OS. Node.js apps are very flexible in how they can be deployed. They can be installed on many types of Linux servers as well as Mac OS and Windows. In fact, Microsoft has provided support for Node.js in their Web Matrix development tool for quite some time. Because of the variety of deployment scenarios and the probability that people considering this option are competent with their server OS of choice, we'll focus on the concepts behind deploying your application. Our emphasis will be on performance and security. If you've deployed a static HTML app or a PHP app, these steps will seem surprisingly complicated. One of the reasons why PHP and HTML apps are so popular is because you simply have to upload your code and it just works. Most other web developers have to deal with extra steps. That said, Node.js is relatively simple compared to some other frameworks. Node.js runs as a single process, separate from the web server. We'll discuss this in greater detail throughout this video, but for now, the important thing to note is that you need a tool that runs your Node.js application. Forever and Foreman are both good choices. They can detect if Node.js has crashed and restart the server if needed. Sometimes your code may have a rare bug that causes it to crash. For example, if a database query times out or returns an invalid response. For security concerns, you'll likely want to run this as a user account that has limited permissions, not as root or administrator. It is common to create a special user just for your Node.js app. If the server is restarted, you want your Node.js app to start automatically. This is done by using the tools your server provides to run as a service. For example, on Ubuntu, you would use Upstart. On Red Hat and Fedora, you would use either Upstart or systemd. On Debian and on other Unix environments, you'd use systeminit. On Windows, you may use Node-Windows. The important thing to consider is that the service is set to start automatically on boot. Some server vendors, for example Red Hat and Ubuntu, do not update software to new versions after the OS is released. Depending on your perspective, this could be a good thing or a bad thing. Therefore, you'll have to consider what version of Node.js is available with your server. Ubuntu 12.04, a popular server Linux distro, ships with a very old version, 0.6. You would not develop a modern Node.js app targeted at that version of Node. The Node.js website has installer packages available, so it may be best to install Node.js that way. Keep in mind that whatever strategy you use, you'll want to consider how to keep your Node.js updated to a version that has the bugs and security problems patched, and balance compatibility. It's also a good idea to use the same version of Node.js on your local computer as you do on your server. Most websites run on port 80 for non-secure connections and port 443 for secure connections. If you choose, you can run your Node.js app on these ports directly. However, this may not be ideal. On Unix operating systems, running a network service on a port less than 1000 requires root or admin access. If there's ever a security issue found with Node.js or your application, it opens the potential for a malicious person to abuse your server. Most people prefer to run Node.js on a special port, for example 3000 or 8000 or some unknown port. This port is in turn firewalled so that it is inaccessible from the internet. Then a traditional web server such as Apache, Nginx, or IIS is configured to proxy request your application. There are many benefits to this scenario, even though it is more complicated. First, you can have the web server serve static content directly so that Node.js doesn't have to. You would do this by creating an alias in your server's configuration that forwards requests from /styleseats, /javascript, /fonts, and /images to the proper folder in your application's public folder. This means that Node.js does less work, keeping it available to serve requests for dynamic content. Another benefit, if your Node.js server becomes overloaded or unavailable, it crashes, the web server can offer a user-friendly error page or redirect the user to some location. A web server also allows you to componentize your app into several separate applications, but group them together as one website. For example, if you use WordPress for your website, but you want to create a custom app in Node.js, you can create an alias for your Node.js app that forwards URLs matching a pattern to Node.js and allow the rest of your site to be handled by WordPress. Keep in mind that popular web servers have had a long history of being closely scrutinized for security problems. I wouldn't go so far as to call them bulletproof, but they've been well hardened over years of service. They can provide a layer of protection in front of your application to shield it from the hostile World Wide Web. If your application would benefit from SSL or TLS, you can easily configure this on the web server. Then your web server can decrypt the request and forward it to your Node.js as standard HTTP, so that your Node.js app doesn't have to know or care about secure protocols. Node.js runs as a single process. If you have a 4-core server, heck, it's not expensive to get an 8 or 16-core server these days, you'll be disappointed to see most of your cores idle. Some web servers allow you to do load balancing. Instead of forwarding all requests for a URL to your Node.js application, you can provide a list of applications, and it will send the first request to one app, the next request to another app, on through the list, in a round-robin manner. If your server is underutilized, you can start multiple Node.js processes, each running on a different port, then have your web server distribute the load between all of them. Keep in mind that you want to allow some headroom. If I were deploying MongoDB and Node.js to a server with 4 cores, I might give half the cores to MongoDB and then start 2 Node.js processes. Then I do some extra load testing to see if I can improve my utilization. During my load test, I'd like to see all 4 cores busy with a little RAM and CPU to spare. Speaking of Mongo, you'll need to ensure that your environment has all the required services available. That means you need to provide a database, probably MongoDB at the least. If your application sends email, you may need an email server as well. If you use Redis for sessions, you'll need that installed too. It's hard to beat Heroku for ease of deployment. There are numerous strategies I've seen used to simplify the process on your own server though. The simplest, and the one I usually do, is create a production tag in my version control system. When I want to deploy, I log into the server and pull down the latest code matching this tag. Once I have that working, I'll often automate it using a continuous integration server such as Jenkins. Another option is to use Capistrano, a Ruby tool, to help you. You may look to see if your version control of choice has commit hooks. For example, Git and Subversion both support this in some fashion. Hooks are scripts that run after you successfully push your code. If your app is quite popular, it might not be feasible to handle the load with a single server. Most companies find it more affordable to have multiple low-cost servers than one mega server. The process I've described above should make it pretty easy for you to scale in this way. Your front-end web server, acting as a load balancer, can just as easily forward requests to Node.js processes running on another server. You'll want to make sure that the load balancer can talk to the Node.js application servers in a secure and fast way, by either being on a private network or connected via VPN. Similarly, if you find that your database server is becoming a bottleneck, you can split it off into its own server and even scale it out to multiple servers. MongoDB is so popular, largely because it is built to be scaled to handle massive datasets. I know of Mongo datasets that are over 100 terabytes in size that are used to generate detailed reports in a fraction of a second. You have a lot of choices. If you already have staff that can manage servers, then you may find that hosting the app on your own server provides flexibility, performance, and cost benefits. If you'd rather not worry about server management, past solutions are very tempting. This video ends this section on deployment, and we're nearing the end of the video series. We have one last section that contains some final thoughts to consider as your app grows beyond the basic capabilities we've described so far. In this last section, we're going to quickly cover a few advanced topics for you to explore once you've got a handle on the basics that we've described throughout the rest of the series. None of these are tools that you need to use, though I'd suggest this first topic to be very healthy to incorporate into your processes. Any JavaScript code used by Node.js is a module. In order to be useful, a module should set a value to the module.exports property. This makes some of the code in the module available for other modules to use. For example, if we look at our contacts route, you'll see the last line sets a value to module.exports. One of the hardest things about creating modules is to decide where they should go. We used a lot of modules and set them as dependencies in our package.json. If you have a module that is useful for multiple apps, you can do this. Instead of just providing a name and version, you provide a path to a Git repo, or you can publish your module to NPM if it's useful to others. If the module isn't useful to others, you can just create a JavaScript file wherever it is convenient. I sometimes make a helpers folder for code that is specific to just one project. Remember to use the correct paths when requiring a local module. If your module is installed via package.json or NPM, then you just put quotes around the module name. Otherwise, you'll need to use a path. Keeping your code clean helps improve the maintainability. For example, a feature I'd like to add is the ability to tie 2 profiles together. If a user creates their account using Twitter login, then later logs in with Facebook, I'd like to try and detect these 2 and tie the profiles together. Now that I have all of the account lookup code in one place, I only have to change it once. Next, let's talk about another tool for making your code more maintainable. When Ruby on Rails came out, it shocked me with how easy it was to write apps that did most of the work I needed to do. It was able to boost productivity because it was an opinionated MVC framework. That meant that it made a set of assumptions about how I wanted to build my app. If I agreed with these assumptions, a lot of the work was done for me. I never got into Ruby. At the time, I worked for a company that did Python and JavaScript, and my love was for JavaScript. Now there is a JavaScript tool called Sales.js which shares the spirit of Rails. It uses the concepts of models, which are definitions of how your data is stored, controllers, which work pretty similar to the routes we wrote, and templates, which are like our Jade files, though it defaults to using EJS as the template language. If you create apps that provide RESTful endpoints, you'll love it. With a single command, you can create your model, and if you accept the default behaviors, you'll get a controller for free. All you have to do is define your data structure and create a template, and you automatically have the code needed to create, edit, and delete data from a database. Sales.js uses a database adapter called Waterline, which gives you a data model based on relational databases. It does have an adapter to use MongoDB, but you don't get all the features of Mongo yet. In practice, this hasn't limited me in any way. The problem a lot of people have with Rails, and the one you may have with Sails.js, is that it works on the assumption that you're okay with the developer's opinions of how you should structure your project. If you're not okay with it, you'll be swimming upstream the whole way, fighting the system. You won't likely get any benefit. I encourage you to give it a try and decide if it's right for you. It does a lot of the easy and moderately challenging stuff for you automatically, so that you can focus on the interesting challenges of developing your app. Next, we'll discuss a popular blogging tool built with Node.js. In addition to reviewing tools that help us be more productive, it's good to look at the work of others. Ghost is a blogging tool that, like WordPress, is both a service that you pay for and an open source project you can download and use for free. It has an active developer community and a successful ecosystem of free and paid add-ons. In order to download the blogging platform, you'll need to visit their GitHub page. If you go to ghost.org and then scroll down, you'll see an icon for GitHub in their footer. Everywhere else on their website, they only talk about their commercial blogging platform. Ghost is a simple, basic blogging tool. It foregoes some of the bells and whistles of more complicated tools and focuses just on simple blogging. You can create posts and pages and upload media, and it has an interface that encourages you to focus on creating content, not formatting. If you download the zip file, which is a suggested way, you simply have to run npm install -- production and then npm start to start the web server. There's really nothing magical about it. It's just Node.js, Express, and some helper modules. One of the easiest things to customize is a theme. You'll see that it comes with a single theme called Casper, though more are available for free or commercially. Themes are built with the Handlebars template system, which I think is an excellent choice because it gives us the familiarity of HTML and just enough templating power to have fun without getting into trouble. The code is in the core folder, and you can browse through it in your favorite editor, or you can browse through it online at GitHub. Something you may find interesting and helpful is their suite of tests. The project has an extensive test suite which you can use as inspiration as you write your own tests. Ghost is a great tool to use as an example and a fun blogging platform. One of the best things you can learn from it is how to structure your app as it grows more complicated. Like many popular apps, Ghost has a small core with much of their code broken out into modules. That finishes up this video. Next, we'll talk about integrating with client-side MVC tools. Client-side MVC tools are very popular these days. Backbone.js helped launch the fad, followed up by Ember.js and Angular. There's a lot of buzz right now around the mean stack, which is MongoDB, Express.js, Angular, and Node.js. You may want to know what you should do in order to accommodate MVC libraries such as these. The good news is you don't have to do a lot that we haven't already covered. At the heart of a lot of these tools are simple AJAX requests that interact with your application in a standard RESTful way. REST is a philosophy on how to simply create web servers by building on top of standard HTTP concepts. For example, the standard GET method is used when you want to get information from the server. What a crazy idea, right? You use post, put, and delete methods to create, edit, and delete records. You typically structure your URLs such that you have /collection, /:ID. So, for example, /contacts is a list of all contacts, and /contacts/1 is the resource for contact with ID 1. We've been using this style throughout the whole video series. We've also used the method override middleware, which is needed to simulate put and delete using standard HTML forms. This gives us support for all browsers in addition to web services. Express.js provides a helper function to make our code a little cleaner, the res.format method, which allows Express to detect if the request expects an AJAX or HTML response. As long as you follow these RESTful conventions, you'll find it quite easy to support the latest MVC frameworks. As a matter of fact, it's so easy, you're likely to make your Java and PHP developer friends quite jealous. Now you know that you're ready to support popular MVC frameworks. Next, we'll take a look at socket.io and WebSocket support. One exciting feature of Node.js is the easy support of the WebSocket protocol using socket.io. This module allows you to easily add WebSocket support to your Express app. In a typical app, the browser can send data to the server anytime it likes by using AJAX. This could be when the user clicks a button, or it could be that a certain amount of time has passed and the app needs to check for updates. Wouldn't it be more efficient if the browser didn't have to continually check the server for information? Instead, the server could just notify the browser when updates were ready. You may have heard of this before because a precursor to WebSockets was CometD, otherwise known as long poll. This was a client-side solution that would make a standard HTTP request and keep the connection open as long as it could. It was rough, but as browsers started supporting the WebSocket protocol, CometD adapted to support it. Socket.io is a library that takes a variety of methods and bundles them into a solution. When you visit a socket.io enabled website with a browser that supports WebSockets, you'll use that style of connection. If you visit using an unsupported browser, it will fall back to a comet-D long pole style of connection. You can create real-time collaborative apps with socket.io. The simplest to imagine is a chat app. When a new user logs into a chat server, they make a WebSocket connection. All the other people connected to that server will be notified instantly when they type a message. Another idea is document collaboration. If you've used a feature in Google Drive that allows multiple people to work on a document at once, then you get the idea. Socket.io deserves a tutorial in itself, but the beautiful thing is that it's well integrated with Node.js and Express, so adding it to your app is not difficult. Just like you might have the onClick event in the browser, your server side will have an onConnect event that executes some code. You can also generate events that will either be captured on the server side or the browser side. You can do this either from Node.js or from the client. Then you write code that listens for these events. For example, your server side can listen to the onChatMessage event, and then your browser can emit a chat message event when a user sends a message to the chat. The server receiving the event will then emit its own event. For example, message received, and then all of the browsers who are listening to that event will know that someone put a message in the chat room. Here's a simple app my son and I wrote to facilitate playing games with friends over the internet. Everyone who visits the web page at the same time sees the same dice roll instantly. We can demonstrate it by opening two different browsers and watching the effect. Note that we have both Safari and Firefox showing the app. Remember our Contacts app? You could use socket.io so that anytime someone adds a comment to a contact, everyone browsing the site would be notified. Or if you're viewing the contact list and a new contact is added, it will be pushed onto the bottom of the list without having to refresh. WebSockets are still an emerging technology, but it has the potential to make the web more useful and fun. Tools such as socket.io make it easy enough that you can incorporate them into your app in as little as an hour. We're almost to the end of our section, so in the next and final video, we'll quickly rehash what we've learned and how you can start putting this new knowledge to work. This is the end of the series. Writing advanced applications takes a variety of skills. Obviously, you'll need an understanding of the platform, which is what we focused on in this series. You also need to have a good understanding of the programming language and data storage and a user experience that meets your end user's goals. These next steps are the fun part. Let's review what we've covered. We've installed Node.js, Express.js, and its dependencies. We've learned the Jade template language, Stylus, and Bootstrap, and discussed some of the other comparable tools at our disposal. We've learned how to test our apps in order to ensure they're robust. We've learned about the Mongo database and the Mongoose adapter. We've built authentication mechanisms using a local database, as well as Facebook and Twitter. And we've discussed strategies for deploying our apps. We've also explored how to make our apps more maintainable by creating our own modules, leveraging client-side AJAX and MVC tools and real-time apps using socket.io. Now that your tool belt is complete, I can't wait to see the great apps you'll build.